That isn't even a topic. Why should that be a topic? Why should we need a physicist to tell us that when we drop something, listen to this, when we drop something, we're debating if the actual thing we dropped is dropping. Now, man, that is beyond the pale. Like,
Well, it's easy to
Yeah,
cast what I said to make it sound silly. But as I said many times, I can interpret either the Newtonian model or the relativistic model the way everyday life shows it. And yeah, in everyday life, we say,
yeah, and you said
and it's a reasonable thing
mainstream.
to say, that the thing falls to the earth. I get that. But I'm just saying that if you want to talk about acceleration, the best way to do it is to use a device that measures acceleration. And a device that measures acceleration will tell you that the ball is not accelerating, and it will tell you that the surface of the earth is.
Yeah, but you told
so the
me the
device spoke
mainstream.
to you and
You
told
told
you
me the
something?
mainstream understanding. Hold on, I see. You told me the mainstream understanding was that in PhD level that when you drop something, they don't know what's moving. They don't know which one's moving, the ground or the object, right?
Well, once again, you have to be clear about whether, when you say moving, do you mean what its velocity is or what its acceleration is?
Knock it off,
Mo-
man. Knock
mo-
it off. You don't understand when we say you pick up something, you lift it, and you drop it. You need to science that? Really?
No, I don't need to science that. I just, if people asked a question, I was answering it. I know that when I drop an object, it will fall to the ground. I know that.
End of
yeah, but is
story.
it the ground
Nothing
moving?
else needs
But
to
is
be
it the
said
ground
after that.
moving or the? Just relax, Essie. But is it the ground moving or the object moving?
Okay, so two questions. Are you talking about velocity or acceleration? And the other question is, do you want me to answer you in terms of the Newtonian paradigm or the relativistic paradigm?
I would just like to answer in reality, and I'm talking about moving, accelerating, moving, not accelerating without moving. I'm talking about they're getting closer together. So which one's moving? Are they both moving towards each other? Is one just moving? And
Well,
I'd like to
all we
answer in
can,
reality. No
yeah,
predetermined.
in reality, the only thing we know in reality is that they're getting closer together. That's the only thing we know. We can see that. That's a directly observed fact that they're getting closer together. And so
Right. So it's the mainstream.
at least one of them has to be moving relative to the other, and they could be both moving relative to each other. You can interpret that any way you want, but one thing that's clear is that they're getting closer together. That's a directly observed fact.
So the the PhD physicist, that level of physics, they don't know which one's moving in reality.
We don't know anything in reality. We know what we know. Well, so we do know that in reality they are getting closer together. That's what we know. There's no need to know more than that, and it's all you can possibly know.
Okay, so my statement, I don't know why you sound like you're disagreeing with me, but it sounds like you said the same exact thing I said. You don't know which one's
Good. Then
actually moving in reality.
I don't see why there should be any disagreement. We both agree on the only thing that one can possibly verify, and that is that they get closer together.
Okay, that's fine. We're not disagreeing. You just sound like you're disagreeing with me, but I'm
Yeah,
saying the
it's
same
the
thing you're
tone, John. It's the tone.
Why
We're
is
not
it my
disagreeing, mate.
tone? Why is it my tone and not the mocking tone of a PhD physicist, and the fact that the idea that a PhD physicist can't tell whether a ball drops? That tone doesn't matter. Mine
No, I'm
does.
saying you guys don't know. No, I'm not trying to mock you or nothing. I just want to get this straight. That the mainstream understanding, like the mainstream PhD understanding level of when you drop something, is that you don't actually know in reality which one's moving. That's fine. We agree. I just wanted to
Okay,
make sure I was
good.
clear. That's why I need to talk to another physicist because I can't believe that's actually true.
I think other physicists might actually, you might find that at first they would say, "Oh yeah, no, we know that the ball is moving" or something like that. But if you allowed that person to think about it a little bit more, you allowed us to talk to each other, that other PhD physicist would agree 100% with everything I've said because it's trivial.
So you don't
Let's
think
get
we're
let
on a globe? You don't think we're on a globe then?
I don't know what that has to do with anything.
Because if you drop something from either side of the globe, you would, and the globe's not getting bigger, it would have to be the object was the one moving, the object you drop.
Yeah, I understand the compelling nature of that argument. And that's because, as I've said before, it's because you don't understand the general theory of relativity. And that's fine. You can think about it in Newtonian terms and get the answer that you prefer, and that's true. It works, right? But we do know that the Newtonian gravity, the Newtonian mechanics is wrong because it makes predictions that aren't borne out, that do not comport with directly observed facts. So we happen to know that Newtonian mechanics is wrong. That doesn't mean it's not incredibly useful. It works really well. It just doesn't get things exactly right. So it's wrong.
Okay, you
Hey,
started
this
off
could
by
be a
just ad
separate topic.
homing me. I do understand what.
This could be a separate topic, but if
Can I just
we go
respond
back
to
to
that
like,
real quick? Because he ad homed me and then went on to say some other stuff. So just real quick.
well, you guys are kind of going in circles, so I was trying to add to it.
All right, go ahead. We'll just let that fly, I guess.
Well, if he's got a response,
No, I'm good.
What do you mean if he's got a
if we go,
response? I was trying to respond.
oh,
What the
go
fuck?
ahead, bro. Sorry, my ears acting up today. Go
I'm
ahead.
good, man. This doesn't go anywhere. Yeah, go. No, go ahead. I just wanted to make sure
Um,
I had the understanding of the mainstream physicist, PhD level.
yeah. So if we go back to a few days ago when we were talking about Airy's failure, I mean, doesn't that give some kind of conclusive evidence that you can decide what's moving compared to another? Or how does
Absolutely.
relativity have anything to do with that observation?
Yeah, it's interesting. Is this Alan? Who am I talking to?
This is Riggs. It's not
Riggs.
Alan.
Okay. But
I
I
want
think
to
I was
go next
talking with
after, please.
I think I was talking to Alan after that. And it opened up, it was interesting to me because it made me realize that there were aspects that I hadn't fully appreciated before. So I went back and dug into it and read a little, especially out of a book. I should put a link to it by a friend of mine, Tony French, on special relativity, where he talks about Airy's failures relation to Fizeau's experiment and the frame dragging. They're not frame dragging, light dragging. That all was understood in terms of Fresnel's theory at the time that water drags light with it at a speed some fraction of the water's speed, and all of that was rooted in ether theory, whether it was said explicitly or not. So a lot of the debate the other night was about whether the Aries failure had anything to do with the ether, and it's easy to cast it as though it didn't, but that's really just a reflection of the fact that the ether was not something anybody even questioned at the time. The idea of motion, they talked about the motion of the earth. Well, that motion, of course, was with respect to the ether, had to be, or with respect to something. It was the idea that there were absolute velocities. Every experiment, including the Aries failure experiment, ends up confirming the fact that there is no such thing as absolute velocity. There's no way to tell how fast you're moving with measurements that are entirely local. In other words, you can't, only by looking at something else can you say how fast something is moving, right? You know that either it or you are moving now, but you still can't tell which one is moving. There's no such thing as absolute velocity. There's only relative velocity. Sorry, I went on a little long there.
No, it's okay. I just
Go ahead, Rick.
I just think it's a little bit disingenuous to interject with some kind of ether argument when we're not talking about ether. Because we're just talking about the light going through water, but we're not talking about ether at all. So
Right, but you'll notice that in the language of the Aries thing, people always talk about because of the motion of the Earth, and it's never the motion of the Earth relative to something. It's just the motion of the Earth. The understanding at the time of the ether was so nobody questioned the existence of the ether. That was just a fact of the time. There had to be an ether because light couldn't possibly just move without having a medium, because it was a wave. It was understood that it was a wave at that time. There had to be a medium, and so the understanding of ether was embedded in everything that people did. That's why it was called a failure.
Different ether theories, right? There are different ether theories, I guess, and so they were invoking what a stationary ether, and that ether just happened to deflect this light into a direction that was favorable to some kind of equivalent relativistic excuse. I just don't see what it has to do at this point. Like if there was a moving ether, it still wouldn't have anything to do with this observation, because when we're using apparent light sources, all it really matters is the telescope or the apparatus you're measuring your observation with. So if the sun is actually beyond the horizon, but because of refraction, it's above the horizon during sunset, right? If I'm looking at it with a telescope, the angle could still change. So it's all about apparent light.
I'm sorry,
So
I just didn't understand.
Okay,
What do you mean
what
by
I'm saying is that
change?
even if there were an ether, and in our conception, we appeal to like this ether has some kind of vortexual motion to it. That action wouldn't necessarily matter in the frame of the telescope. It would matter from like wherever the sun actually is or wherever the star actually is, and that action would take place into how it is moved apparently to your location. So while the ether is real phenomena that we're believing in, it's not relevant to this part of the discussion, because we're using the apparent light source from no matter where it is, and we're just looking at the telescope in the water. So when it deflects in a different direction, it just makes it definitive that one item is moving rather than another. Like we don't have to concern ourselves with ether.
You're
That's what I
absolutely
think.
correct.
Can we go back to motion before we veer off the ether? I mean, if he wants to answer that, I want to ask him a couple of questions.
I'm trying to get away
Motion.
from.
I was patiently waiting.
I'm trying to get away from ether.
Yeah, that he's trying to. So to your right, Riggs. In none of the math equations used to calculate Airy's failure, neither in the ones in like the special relativity textbooks that talk about like the length of the telescope being ratioed against refractive index, or anything else, there's never a variable for ether. Now, the thing is with or without ether, the math is exactly the same. The prediction's exactly the same. When you use modern math that doesn't incorporate ether at all, it's still the same as they used back then. The only way that ether even comes into it is they believed that ether, the compressedness of ether, was responsible physically for creating a refractive index. They thought the refractive index was a reflection of how compressed ether was inside of a material. But with or without ether, a refractive index is still measurable. It's still real. It still slows light down, right? Like all of that is still true with or without ether. So saying it was about ether does nothing to change the implications of the observations in Airy's experiment. You can take ether completely out of the picture and just use the modern framework and the photon model of light and everything. You still have a huge problem, because both with the classical math and adding a correction for relativity, which only changes it by like 2/10 millionths of a percent, you get the same result, that there should have been about a 6.8 or 6.9 arc second angle change, and there was not.
Yeah, absolutely, Piezo. The point we're trying to say is that the refractive index is separate from ether refractive index theory or whatever they thought that was. So there's just no, you're not playing with a full deck of explanation. All right. So we're not seeing why the relationship is not indicating, that one is moving separate from another. Like this is a totally separate thing. The refractive index is separate from ether.
What's super funny, Riggs, is actually in a book, a textbook that we actually got from John just the other day. We went to the section in it where it talks about Airy's failure, and it literally goes through all the math for it, and obviously the math does predict an angle change, and it says in the last concluding paragraph, it says, it is quite curious that nature would give a refractive index in our experiment that would be just simply so what it would need to be to match that of an Earth that's stationary or whatever. Like they try to say that like a stationary Earth, its predictions are the same exact as what they got, but it's because there's some magical by consequential chance of like winning the cosmic lottery that's what the Fresnel drag coefficient ended up being to match that. And that's actually not the case, because that would be assuming, depending on how you look at it, like a refractive index or a Fresnel drag ratio of either a 0 or a 1, and it was neither of those. It's like 0.437. It's like 43.7. So
I mean, this is a prime example of just like leading with your bias and just like totally missing the point.
And then they just go on to, like, is there an experiment where we can show a positive effect of a Fresnel drag coefficient having a measurable effect in the lab? Sure, there is. And then they talk about the Fresnel drag experiment. They don't mention another word about Airy at all. They just appeal to this actually factually not numerically true explanation about, oh, it just so happens that nature has curiously provided us with the exact coefficient we would need so that the observations would match that of a stationary Earth. Like, no, it didn't. That wouldn't even work even if it was true. And factually, that's not the coefficient either. 43.7% is not what would do that. But
so here's what I learned doing more research after. I mean, I looked into things. I heard about this guy Clinker Fuse for the first time. I read his paper. I read Airy's paper, and I came to, and it was fascinating. I really did learn things that I didn't know, and I think I now understand why Airy's failure was called a failure better than I did before. Stellar aberration, the fact that one has to point a telescope kind of 20 arc seconds in the direction of motion of the Earth, was understood by everybody as being because of the motion of the Earth at the time, right? The motion of the Earth, because everybody understood that it goes around the sun 30 kilometers per second. 30 kilometers per second divided by the speed of light gives you that 20 arc seconds that had been observed by Bradley 100 years earlier, right? 1725, Bradley observed the aberration of light. And didn't have I don't know what Bradley thought. I think he might have had estimates for aberration because he knew that the Earth was rotating around the sun as well. But that whole aberration angle is probably one of the best pieces of evidence because it's hard to explain without the Earth rotating around the sun. So you have that going. Then you have Clinker Fuse, who says, oh, this means that if I fill my telescope with water, I will be able to detect the speed of the ether. It's not a matter of, it wasn't a question of whether there was an ether or not. He knew there was an ether. Everybody knew there was an ether. There had to be an ether. And so he was going to detect the velocity, and he measured that angle that he had to move his telescope because of when it was filled with water, and he got a value of about 7 arc seconds. The expected value is about 8 arc seconds due to the drag, that 0.43 drag coefficient. And he got essentially that value, but then he didn't repeat the experiment. Nobody else did. So all Airy was doing was trying to repeat the experiment and kind of, get a little more precise value than Clinker Fuse had gotten. And then Airy did it several times, and he simply couldn't couldn't detect any need to rotate the telescope at all. And that wasn't something that indicated anything about the ether. That 8-second thing had to be there, and it was just a matter of kind of seeing the effect of the ether. And the fact that he didn't measure it wasn't something that they interpreted in any way other than a failure, right? It had to be there. But then they looked at the Piezo's experiment, Fresnel's explanation for that, and it turns out that the same explanation, Piezo explaining both of them in terms of the dragging of the ether by water, explains both of those things. And it is curious that you get the same explanation once you do experiments that finally rule out the ether, like Michelson and Morley did. Not rule out the ether, but rule out any detectability of the ether. Once you know that it can't be detected, then Einstein came up with a theory that said, well, if you can't detect it, maybe it doesn't exist. So he came up with another theory, just says the speed of light is what it is, period. And then worked out the consequences and showed, as Fresnel did, that he explained it in this. He explained both the Piezo and the Airy's failure in terms of his theory, which is nicer because it doesn't require the existence of a thing that can't be detected.
Did anyone get all that?
Yeah, Klinkerfuse used oil, not water. His experiment was a little different, but I mean, close enough, I suppose. However, Airy was like, Klinkerfuse to use this little small telescope, and he did this one set of measurements. I want to do this big time and really make sure that what he thinks he's measuring, he really is measuring. Airy's experiment was like many orders of magnitude more precise. If you actually just look at like just the micrometer slit set up in general, the way he was actually measuring the angles to the stars was actually ingenious. He used these micrometer slits in a crisscross pattern that were denoting like one millionth of a degree between each slit as they cross slit. But anyways, he did it, and he didn't measure an angle change, right? And he was like, "This is so curious. This guy's claiming to have gotten exactly what you're supposed to get. We know you're supposed to get it, and he didn't get it. I didn't get it, right? And the problem is even you keep like once again you keep going to ether and saying Einstein took away the ether and it made the prediction work. No, it didn't. Even if you take the ether away, the formula for stellar aberration does not have an ether component. As you said, it's literally the tangent angle is the ratio of the Earth velocity over the light velocity. So if you take the light inside the telescope and you decrease its velocity, it necessarily has to increase the angle, right? If you make the light velocity 3/4, it makes the angle 4/3. And that's what they expected, was to get 4/3 of the normal angle. And they didn't. There's still, to this day, no explanation as to how you could not get an angle change. And the only thing that's even been posited to try and save it without it doesn't actually give any numerics, because we went and actually used the formula for stellar aberration using relativity, and we plugged everything in, and it's 99.99999% the same as the classical, because Earth's velocity is so small on a cosmic scale, it doesn't really matter. That it still doesn't match what they measured. They didn't measure an angle change, and there should be. So to say that, ether solved it, that is simply not true. And there's just, the math is so simple. V over C, right? If you make C 0.75 C, you need 1.33 of the theta angle, and you don't get it. There's no reason you shouldn't. If you make the speed of light C inside the telescope, which is the only other thing they do without numerics, they try to say, oh, well, light still moves at C inside water, even though we know that's not true, but they try to force it on it. Then if you say that light moves at C in water, then as soon as the light's not in the water anymore, prior to entering the telescope, you have it moving faster than C, which violates relativity also axiomatically. So you're not allowed to even have that. You can't just force C to be C everywhere in every single medium just to try to maintain the symmetry of your observations.
Yeah,
Yeah,
well, nobody does. Everybody acknowledges that light travels at a lower speed by about 30% in water than it does in a vacuum. So that's not an issue. And once again, I mean, almost everything you said there, I completely agree with. The Fresnel gave an explanation for both Fizeau's experiment and for the Airy's failure in terms of a theory that didn't deny the existence of the ether. Fresnel's explanation did not deny the existence of the ether. It was
well,
simply
be careful.
a dragging of the water, a dragging of light by water.
But
The
that's not
um,
all. You got to leave. You can't leave out the important part there, John. Just real quick, I want to let you talk. I just want to make sure that you cover it. If you
okay.
read the to Mickles, if you read the opening page, the first page of the Mickelson Morley paper, they actually point back to Airy, right, as like being one of the main reasons they're even doing this experiment in the first place.
Mhm.
And they talk about it in the body, and they also talk about it in the footnote. And they say how in both theories of light, because you got to remember, everybody was trying to force the Earth to be in motion in their explanations. In order to use that as an explanation and then say like, oh, it's like ether carrying a certain percentage of the velocity, they actually had to have it being carrying the velocity in the opposite direction to the motion. Like it's completely backwards. And Mickelson points this out in their paper and laughs at it, like makes fun, like this how absurd it is. And he talks about how, the undulatory theory, you'd have to have that. You'd have all these problems, and the emission theory is even worse because you'd have to have it going in the opposite direction. So both theories, neither one offered a satisfactory explanation. So they're like, okay, we're going to get some interferometry going now. But the reason that neither one offers a satisfactory
Let me know
explanation is
when
because
you're finished.
both the explanations they were giving forced Earth to be in motion. If you simply let Earth be at rest, it resolves all the contradictions. You don't need to invoke like opposite direction velocity components added horizontally to the water.
Yeah, I think you may be right in the sense that you're right until, of course, you put interferometers in space, which would be moving. And I don't know whether we've done that. So it is true that you can resolve certain problems by letting the Earth not move. That wasn't on the table for Fresnel, for Aries, for Mixon Morley, all those people. It was well known that the Earth is rotating around the sun, and one of the clearest pieces of evidence for that is the aberration of starlight. The aberration of starlight does what it has to do in both relativity and in classical physics
Hold on.
when you have the Earth going around the sun.
So I think what just happened is that we got a very
Affirmative comment.
soft concession. We got a very soft concession, and now we're moving to starlight aberration, which is fine. I just want to
Yeah,
note that we got a very soft concession there.
right. But let me be clear. I mean, the problem is that if you actually use that to say that the explanation is not the lack of ether, but the lack of motion of the Earth, and if you do that in order to try to deny relativity, now you're on difficult ground because relativity gets observations right where Newtonian pre-relativity doesn't. The theory based on the lack of existence of the ether makes predictions that the theory based on the Earth being still and there
But
being
not
the
enough
ether
predictions. That's the problem.
fail to provide. So there is that. But I just wanted to stick to you're right up until like 1900, etc. That one could have solved the problem simply by saying the Earth doesn't move. But that wasn't on the table. Everybody doing these experiments understood that the Earth is moving and that the aberration was just an undeniable piece of evidence for that. You couldn't get stellar aberration doing what it was doing without the Earth moving 30 kilometers per second this way at one time of year and 30 kilometers per second the other way 6 months later.
So are you guys done with the ether talk? So we can go maybe back to a little bit of a motion of the dropping. I'd like
I
to
was
get some
hoping
clarity
Piezo had a
there.
response, but if you got something else you need to move to,
No, we were actually on
Can't respond
something
right now.
else, and
I
you
can
guys
check.
moved on to this, and we were like patient, like we went back and forth for
okay.
like what, half an hour now? But I
Well,
don't mind. I
I
can wait some more.
apologize.
No,
I mean,
I do want to.
has this
I
not been
do
helpful
want
for
to.
everybody?
I do want to hear a response from Piezo regarding stellar aberration. How that's also possible with a geostationary Earth.
Whatever the audience wants. Because I think this is a little bit over most people's heads, right? Like I want to go back to just like a simple motion, but I'm very patient. I can wait. You can talk about ethers and aberrations, and I'm very patient. I can wait, but I do want to get my question in.
Did you have
Absolutely.
like a quick
PhD.
question or something that you wanted to grace us with real quick? I mean, if he's busy, he's busy.
No, there's nothing real quick about it. Like I said, I'm very patient.
Okay.
I just
All right.
want
Well,
to
you
say
sound very patient.
before we move on, I just want to say that I do believe that both stellar aberration and stellar parallax are not exclusive to the globe model.
Yeah.
That those
Not a
are real.
globe. It's a
those
geocentrism thing.
those are real phenomena, and I'm not denying them, but they can be explained.
Looks
They
like
have
Piezo's back.
equivalent.
get
Yeah.
in.
Also, Lon, sorry, I had to go for just a second. I had to take something real quick, but to invoke aberration as a proof of Earth motion because they just already knew it was right. Well, I mean that was James Bradley's claim. They weren't seeking to test it because they just a priori presumed it to be true. But then when Airy did his experiment, it showed the opposite. So you like the results of
That's
Airy's
wrong.
experiment.
That's just wrong.
The results of Airy's experiment, right? The implications of it show that well, the angle is based on the velocity. So if we change one of the velocities, we should get a change in angle. Well, we did change
No,
velocity. We didn't get a
no,
change
no,
in
no,
angle.
no,
Oh, that's
no, no,
cheating.
no, no. You're
But,
really misunderstanding that.
John,
I'm sorry, that's
John,
just
you
wrong.
cannot.
But
No,
you can
it
go
doesn't
ahead.
matter if you think that you can't just interject and cut in whenever you want.
anyway, so like you can't claim aberration to be this exclusive proof of Earth motion when literally they modified the controlling parameter of aberration, namely the velocity component. When they changed the velocity component, the aberration did not change. That would show one that, oh, wow, it looks like the aberration is not based on the ratio of these two velocities. Wow, because that was the claim before, right? Well, if you change one of the two variables and the result doesn't change, then that means the result can't be based on those two variables, or else it would have changed. So that's why aberration can't be just claimed as exclusive proof of Earth motion. And then everybody knows parallax can be completely easily equivalent on a geocentric model. They don't even teach it like that. It's actually just a simple diagram to explain parallax. Parallax is much easier to explain.
Thank you.
So
Yeah.
that's right. So parallax is based on the position of the Earth changing over time. The stellar aberration is based on the velocity of the Earth changing over time. Both of them are exactly what you would expect, given the fact that the Earth revolves around the sun with an orbit of 93 million miles. So both of those things are consistent with what we observe. Now you can say, maybe it's something else. Yeah, maybe it's something else. But I'm going to get back to the aberration thing, because the aberration is based on the fact that the Earth's velocity is whatever it is. You don't have to, relative to things, it is something. And then 6 months later, it's 60 kilometers per second, something else in the other direction, right? Whatever. It's a different velocity. It's not about what velocity it is. It's that it's a different velocity. Stellar aberration, all but requires that. If you have some explanation of stellar aberration that doesn't include that, then I don't know. I don't know what it is. I guess I'd be curious to see that. But that's a completely separate argument, Now,
Skies are just
completely
moving. Like
completely
the stars
separate
are
argument
just moving.
from the what happened in Airy's failure. Airy's was trying now not to just show that the velocity changed by 60 kilometers per second, but to actually measure the motion of the Earth
So
through the ether that was a result of that. We didn't know how fast the ether was going. All we knew is that the Earth changed its velocity with respect to it. And so when he found that he got no deviation, that wasn't a possibility. That there had to be a deviation when he put water in the telescope, because he knew that the Earth could not be. It might not be moving right now, but if it wasn't moving right now, then it had to be moving 6 months later. The fact that part of it didn't change meant that at the very least he couldn't detect the ether, and that was a mystery because they didn't allow for the possibility that there wasn't an ether. It had to be detectable, and they'd failed.
The point of the experiment was not to detect ether, bro. Like saying
Right,
that they didn't detect.
exactly. It was to measure the velocity of the Earth.
Let's use some. I mean, it was actually to measure the change in refractive index based on the motion of the Earth. But what they failed to do was measure the motion of the Earth. Right. That's the
Right,
implication. And so,
right,
doesn't matter if you have ether or not. We use the 2024 definition and formula for stellar aberration to the modern day. If I use today's formula and
right.
if I presume ether does not exist, and me and you agree ether does not exist, and then we go look at the results of Airy's experiment, how does that do anything to remedy the situation that he measured no angle change? There still should be an angle change with or without ether. The ether
No,
existing or
that's
not
just
does
not
not.
true. Sorry, sorry. I thought you were saying.
The
You asked me a
formula
question, so I just
literally
wanted to
is
answer it.
the formula is tangent theta equals v over c. That's the formula we still
Right,
use to this day, and it doesn't matter.
relativity or not.
It doesn't incorporate ether, bro. So if we make c
Right.
3/4 c, then the angle changes, and he didn't
No,
get that,
it's not true. So
bro.
a lot of what
If
you
I take
say is
wait,
right.
wait. If you disagree, I'll let you, bro. I'll let you answer. But you just said no to the fact that if I take tangent theta equals v over c, right? I have a fraction on the right. We leave v the same because you can't make Earth slow down, and you take c and you make it 3/4 c. Are you saying that the tangent theta angle on the left side of the equal sign wouldn't change? So the right side of the equal sign has changed, but the left side of the equal sign won't change? Is that what you're saying?
Look, I recognize this is difficult to understand, but the point is that it's the
What?
speed of what we measure with aberration is how much the speed changes over 6 months. And that's
Right.
true in relativity or not. It's not the speed of the Earth that changes. It's the speed of the Earth relative to the stars that changes. Um, that speed was just understood at the time of Airy. It was understood that if the speed changes, that's an absolute speed that would change with respect to the ether, and therefore that additional 8 seconds of arc had to be there. It wasn't a question of. It wasn't a question of. Is there an ether or not? It had to be there, and it
You're not
wasn't.
answering my question, Don.
That okay? So what's your question? One more time. I thought I
I've
was
got I've got tangent theta. We don't know what theta
right.
is.
But
I'll
yeah, no,
figure it
I
out.
know. I'm answering the question. I get it. The
So
v
it's on the
in that
left.
equation. The
We've got
v in that equation is the velocity of the Earth. The Earth doesn't have a velocity. There's no such thing as absolute velocity. So in
okay,
that
Don. And
equation,
if it doesn't,
it only has a velocity relative to the stars. This is the part that's really hard to understand unless you really do understand relativity. It was the thing that made what Einstein did so revolutionary, because he was really thinking out of the box. He started with the assumption that essentially that there's no ether because it can't be detected. What that amounted to is the fact that you cannot talk about, quote, the velocity of an object. Objects don't have velocities. They only have velocities relative to other things. And in the theory of
but John,
relativity, you still have, I'm almost finished, that in relativity, you still have the velocity of the Earth relative to the stars, the things they're looking at, but you don't have a velocity of Earth. And since you don't have a velocity of Earth, you don't expect that the water-filled telescope will do anything. It's just looking at a star. And that light from that star is just coming down the telescope to the detector.
okay, please keep your answers concise. I'm trying to do my best to keep mine concise as well. There's two problems. One, if you say Earth doesn't have a velocity at all, then you'd have a fat zero for stellar aberration. Either it does or it doesn't. You can't have it both ways, right? So if you say that it doesn't have a velocity at all, and that's why the angle didn't change in water, then you wouldn't have an angle in air either. But we know it does. It's with respect to the stars, right? So
yes, exactly. With respect to the stars.
Okay, so that we assume that the background stars, they're so far away, we treat them in astronomy for all intents and purposes, also in relativity and every framework we have, we treat the background stars as effectively stationary for any calculations involving the Earth. And then when you do that, you can take the velocity of Earth with respect to that. If you change c, it changes the theta angle.
Okay, so once again, so let's just take at a given time, you're on the Earth, you're looking at the stars, you just see them. So this is the I mean, even in classical physics, you would have this. You're on the Earth, you just see the stars. Now in classical physics, you're thinking, okay, but you're looking at them from a moving source, so you're not seeing them where they are. In relativity, you're on the Earth, you're looking at the stars, you are seeing them where they are. That's where they are. And so there's no question. If you fill a telescope with water, it's not going to make any difference because the light from those stars is simply coming to the Earth from those stars. That's where they are. There's nothing to keep it from doing what it does. But if you now accelerate the Earth and make it move in a different direction, those stars are literally in different places. In relativity, space itself has changed. So those stars are not in the positions that they were before. Now, whether that's relative to you, right? But their positions have now changed. You now look at them where they are in your new reference frame and you see them where they are. You can fill your telescope with all the water you want. It's not going to make any difference because you're just looking at stars where they are. And they're now in different positions because you're in a different reference frame. That's one of the weird things about relativity.
I don't know how many times we can go in the same circle and just say the same things over and over. You still have to claim that simultaneously, the aberration that we do see in regular telescopes is caused by the difference in the ratio of the velocities, the velocity of Earth over the velocity of light. And then in the same breath claim that if we reduce the velocity of light, it wouldn't change anything. There's only two variables in the formula. There's literally only two, V and C. If we change C, theta has to change. You cannot have a world in which you change C and theta doesn't change. We made it 3/4 in water. I could make it 1/2 in oil or 1/4 in some super thick stuff. Like, what if I slow light down to 10% of its original speed? Any of these things, well, all of them will change the angle. You can't just say the angle wouldn't change when you change the parameters that control it.
Yeah, and once again, you're just not hearing me. In the case, I understand that what you're giving me is the classical explanation for aberration of light. It has to do with the velocity of the Earth, right? But in the case of relativity, when you take the Earth in one situation, you just start with the Earth, forget about its motion. I don't know what its motion is. Just start with the Earth, looking at stars, you see them where they are, period. That's it. The light's coming down your telescope, you see them where they are. Now, look at those same stars from a different Earth. Don't maybe if you want, just let it be another Earth that is moving at 60 kilometers per second relative to the first Earth. there's going to be a change in the angle at which you see the stars from that second Earth. That's going to depend on that 60 kilometer per second, 60 kilometer per hour per second, right? Speed, and that angle change, that relativistic aberration angle, will be about 40 seconds of arc. Now you can divide that in two and say, well, that's because of 30 kilometers per second this way and 30 kilometers per second the other way. But it's not. It's just another Earth moving at 60 kilometers per second relative to the first one. And in the frame of that second Earth, those stars are in different positions. The aberration is because of the fact that relativistic aberration results from the fact that those stars are literally in different positions. Space changes in a different reference frame. So the relativistic explanation is not a dragging kind of an explanation. It's that the stars themselves are in different positions.
Is the theory of relativity falsifiable?
Yes, easily.
How?
It makes an enormous number of predictions that you can go out and measure. Like for instance, it talks about the release of energy due to nuclear fusion, nuclear fission. It talks about neutrino lifetimes with the measurements. Like it talks about the speeding up of clocks at high altitude. We take atomic clocks into the Rockies and we affirm the most bizarre predictions of relativity, that clocks at higher altitude run faster. Right? If it didn't do that, if we didn't measure that, relativity would be wrong. And it's a bizarre prediction. You wouldn't expect that. You wouldn't even think to make that measurement if relativity didn't make the prediction. It makes the prediction. We go with an attempt to falsify it, to show that it doesn't happen, but it does.
So how do you falsify it?
So you falsify it by taking one way would be to take atomic clocks into the Rockies and show that they run at the same rate they do at sea level. But that doesn't happen. What they actually do is they run faster than they do at sea level. So you failed to falsify. It can be falsified. It just isn't. There's a million ways to falsify relativity because it makes totally bizarre predictions that have been verified by experiment.
So if something can't be falsified, is it science?
No, absolutely not. If it can't be falsified,
so the theory of relativity is not science.
Well, real quick, I just want to say that
I just told you one of a million ways to falsify relativity. It makes the most bizarre predictions, one of which is that atomic clocks should run faster at high altitudes than they do at sea level. So you attempt to falsify relativity by taking an atomic clock to high altitude and showing that it doesn't run faster, and you fail to falsify relativity because, in fact, it is directly observed that atomic clocks do run faster at higher altitude.
we predict the same thing, John.
How did you prove that the altitude was the cause of it spinning faster or reading
I didn't
time
have
fast?
to. I took the clock to high altitude to show that it runs at the same speed that it does at sea level, and I found out that it doesn't.
Why? Because of the altitude?
I don't know. It doesn't matter why. The point is that relativity predicts that it should be faster, so I try to show that it isn't faster, and then I fail to falsify relativity because it does run faster. So you try other things. There's a million things you can test. Relativity makes bizarre predictions.
We set a time limit
on them. You test them to see if you can show that they don't happen. But every time you try to show that they don't happen,
is there a mod here?
That they do.
All right, yo, chill out, bro, chill out. Let people respond.
Yeah. So first of all, I guess we're finished with Aries. I mean, I'm finished going in circles with it. Anybody interested in looking at it, just go to Space Audit's Alan's Obsidian database. You can find the link to it on his YouTube, Space Audits YouTube. Go to the bio and you can find the Obsidian link. It's on his Airy's failure or Airy success page on Obsidian. But as far as what he's talking about now, in order for relativity or to be proven or whatever, or disproven by the change in the clock rate of atomic clocks with respect to altitude, the alternative theory would have to predict something different. And the thing is it doesn't, right? Because in our theory, we have a physical mechanism for the change in an atomic clock's timing, not a metaphysical one, right? Relativity predicts because of, the effects of relativity, space and time changing. That's causing a change in timing, and time is literally warping on that clock. We say that actually the physical mechanism by which an atomic clock operates is you have this cesium atom, and it oscillates at its RF frequency it's being hit with. It oscillates at 9,192,000,000 times a second, right? And so you can break that down into a clock rate. Well, the thing is that's based on it being cooked at a constant frequency inside of that RF chamber inside the clock. When you go to high altitude, the rate at which the ether drift or the light drift occurs increases in magnitude, which causes a frequency shift inside of that RF chamber. And because of that frequency shift, that's why the clock rate changes. It's literally a physical mechanism. It's not this like time itself is slowing down and speeding up. We predict the same thing, but we do it physically, and it's measurable.
Okay, so you measure the rate at which it speeds up, and then you see that amount by which it speeds up is predicted, that the amount, right? Not just that it speeds up, but the numerical amount that it speeds up is predicted by your theory, given the speed of the ether at that altitude that you can measure separately. Is that right?
Well, it's actually ratioed against the velocity of the satellite itself. So when you put a satellite in orbit, right, you've got C plus or minus V of the satellite. So actually there's two corrections, right? The correction for the change in the ether velocity is actually smaller, just to be clear, is actually smaller than that of the satellite itself, and it gets eaten up largely by it. But C plus or minus V is the main component. So I suppose I should have started off with that. I just wanted to connect it to interferometry because we can see the ether drift change with interferometry. But the actual major component, the first order component that affects this velocity clock rate change, is the velocity of the satellite. And when you look at the GPS timing equations, they actually do a plus or minus V of the satellite, right? So the motion of the satellite itself around the Earth is actually causing a change in the clock rate. A stationary satellite at X altitude and a satellite in motion at that same altitude will have different clock rate adjustments, because the actual one of them is just due to the change in altitude being the change in the light drift velocity, and the other one's the actual motion of the satellite itself. And you can't have the motion of the satellite itself creating a clock rate change, because it would need to be with respect to space itself. Because once you bring the clock back down to Earth, right, it should still be synced up. There's an Einsteinian synchronization performed before you ever send it up. So internally, on its own timing, on its own timing system, the not like the time as we measure from Earth. No, the time as we measure from the satellite before and after we launch it and bring it back down has changed.
Okay, so a couple things to respond to there. There's no, you can't, in relativity, you can't synchronize two clocks and then move them apart, move them to different altitudes and expect them to remain synced. A moving clock runs at a different rate than another. Clocks that are moving relative to each other have different rates at which they run, right, as opposed to each other, just like clocks at different altitudes do. So in GPS, we have to make a correction for the speed of the satellite, because that affects the time. That actually slows the time down on the clock on the satellite. And then we have to correct for altitude. which changes the rate, which increases the rate. And then both of those formulas are very specific. Relativity doesn't just say it will slow down and it will get slow down due to speed, speed up due to altitude. It says exactly how much it will slow down and speed up. And that is exactly what we observe for the
That's also
clocks
not
on the
true.
GPS.
That's a
So
false statement.
I just want to point out, I mean, the point is the observations are not just qualitatively what we predict, they're exactly what we predict based on measurements only of the gravitational field of the Earth. That's it, and the speed of the satellite. Right? That's all we do.
objectively
Now,
not what they
your corrections. I think I'm hearing you say that because you know the ether wind as a function of altitude, either because you know that you can calculate the rates and you get the right rates, or you're saying that from the rates of those clocks you can calculate the drift of the ether wind as a function of altitude. Is it one or the other of those things?
I'm disputing your claim that GPS clocks use relativistic corrections to achieve the accuracy.
They absolutely do. You can look that up anywhere. That's trivially easily available information.
Okay,
The
I'm gonna
GPS
talk.
system would not work without the general
I'm
relativistic.
gonna talk now,
correct.
Don. Thank you. So specifically, and you can look at this in the 1996, I want to say, GPS standards that were published on the International Standards for Satellite Navigation, and you can also look at these in subsequent papers since then addressing this very topic. Alan has a very lengthy series of presentations, very complete in terms of explaining all of this information on his YouTube and on his Obsidian database once again. But if you look into the formal publications and you look at people that have actually were brought in to correct GPS used to be off. They found in I think it was the late 70s or early 80s, that when they tried to use GPS for precise location measurements, because that's when they tried to increase the precision, they realized that their GPS range measurement equation was causing them to be off by up to 30 meters in terms of the position of what they were trying to measure. And they couldn't figure out how to fix it. And eventually they fixed it by applying Sagnac corrections, which were specifically C plus or minus V. Now, the magnitude, and you can read these publications, the magnitude of the correction for the Sagnac correction is about 100,000 times greater than the correction due to special relativity. And there's even people that were writing the institutes publishing these standards for geospatial navigation that were talking about like how they thought that it's interesting that they don't have a special relativistic correction in there in the formula, and they think that there should be. There is not. They have two Sagnac corrections. They don't have special relativity corrections. The magnitude of those corrections are tiny compared to the corrections that are actually employed, and they would not correct the satellites by the amount needed to make them accurate. I encourage everyone to go look at the database and look at the presentations to get all this information. It's got the formal papers in there, the links to the papers, all the sources. Go look it up yourself. Don't take this man's word for it, because this is on this particular topic. This is a false claim that is passed around a lot. They tout relativity as like this pinnacle of science that they use in GPS navigation in order to make it work. That's actually not true. It's Sagnac corrections, which are specifically not relativistic and contradict relativity.
Nice, dude. Thank you. Gravy.
Yeah, well, Sagnac effects. I mean, you kind of do disservice. I learned something while you were talking. I was looking up Sagnac effect, and I see that they do take it into account in GPS. But you kind of destroy your point when you say that Sagnac, whatever you said about it, disproving or being falsifying relativity. That's nonsense. Right? Sagnac effect is a real thing, fully understood. And it does not destroy relativity. It's a relativistic effect.
It's been over 110 years since it was discovered, and there is still not one single coherent, unified explanation for the Sagnac effect in terms of relativity.
That's
There's like over
true.
a dozen. It is true. There's over a dozen proposed explanations, and none of them agree with each other. But the most commonly referred to one that's close as they can get, what they do in order to try to make the prediction of the Sagnac effect that you actually measure is, on Sagnac's table, it's got a rotating table where the detector and the emitter are both at equal distance from the center of the table. They're both on the rim. So they're both at the rim, equidistant from the center. When you spin the table, you get a fringe pattern perfectly proportional to the velocity with which the table spins. You can also put the emitter and detector on a stationary wall in the lab and just put mirrors on the table and shoot the light at the mirrors and spin the table and reflect it back to the stationary wall, get the same exact thing. In order to try and explain this, the closest they've come, and it's still completely void as an actual physical explanation, is they do a coordinate system transform and they treat the observer as if the observer was at the center of the table. Because the center of the table is the only place in which there's not actually any rotation. In any rotating system, the center of the axis of rotation is an inertial point. So they take all the measurements in the coordinate system transform with respect to the center of the table. Well, that destroys the point because then you create relative motion between the center of the table and the rim. All measurements are actually performed at the rim. There's never any relative motion between the emitter and detector in any of the systems measured. There's no relative motion between them at all, yet they detect a velocity proportional fringe shift. That's the Sagnac effect. It completely destroys special relativity, and there's no explanation that explains it physically.
Okay. Well, once again, I mean, first of all, I just concede that I don't know what you're talking about. And that's just literally because I don't know the experiment you're talking about. So if you can send me that, I will take a look at it. If this is something that has been published in any kind of a semi-respectable place, then it will be, and if it does destroy relativity, then that will be the outcome. And science is all about falsification. If this thing you're talking about falsifies relativity, then so be it. That will be the case. But it'll be a heavy lift.
No, it's you have an argument from authority. You're like, if something is true, then it will necessarily
Replaces it.
be the
Will
scientific consensus.
explain the deflection of. Hold just a second.
Can you stop monologuing so much?
Yeah, well, the whole thing he said is authority, is from authority. The whole thing you were talking about with the rim and the edge, that is from authority.
What? I'm talking about an experiment, bro. It's not an appeal to authority at all. He's saying that if relativity
Well, it
was
absolutely is an
falsified,
appeal to authority. The question is we have to examine
you're
the
saying
authority.
if
That's what I'm
relativity,
saying.
Guys, you cannot just cut him off every time he's speaking. Jesus, John, you got to work on this, dude. I know you're new, but like,
you're saying that if relativity was false, then that's what the scientific consensus would adopt. Just automatically, you're like, yep. If whatever's true is what the consensus will be. You're equating the consensus with truth. But if the consensus believes something that's not true, is that possible? Is it possible for there to be a scientific consensus that's wrong?
Yes, it's happened many times.
Many times. Many times.
Okay, then you can't invoke that as like a proof. Then you can't just be like, well, if relativity was disproven, then that's what science would say.
No, but the thing is if you have something that genuinely does, what happens in science is other people, especially something like this, would be an extraordinary claim at this point because relativity has had enormous success. Things that predicting things that Newtonian mechanics completely fails at. So if general relativity is falsified by one thing, there'll be a lot of people that'll be very skeptical, right? They'll need to reproduce that experiment, need to really understand that it does indeed falsify a theory that has had magnificent success. And then the question will be, well, what replaces that? I think you're saying you have an alternate theory. I assume that your alternate theory predicts the kinds of things that happen in particle accelerators, the increase of energy with velocity, momentum, the impenetrability of the speed of light barrier, the rate at which clocks run on GPS. You've already said it does. The bending of starlight, the gravitational radiation, which we now detect, bending of starlight through past eclipses.
Gravitational
all
lensing.
of the things that relativity accounts for, your theory would have to account for if it's the replacement. Now, it's possible to falsify. We falsified Newtonian mechanics before we really knew we had the observations of Mercury. Falsified, turns out. We didn't know that at the time. The consensus was, well, there has to be an explanation for this, just like there would be with your scenario. But it turned out there wasn't an explanation for it. Relativity explained it easily, and so that was one of the big successes, early successes.
Almost all of those examples that you
I
gave
agree.
are touted commonly as quote unquote proofs of relativity.
Not proof.
Are always okay, evidence, whatever, are always presented as relativity is the only thing that could explain these things, and also
No.
it explains them perfectly. And in almost every case, when you actually look into it, it turns out that that's not the case. And if you look at it in a paradigm that doesn't invoke a mystical bending and warping of space-time, which is itself not directly measurable but always inferred via supposition, you find out that, hey, there are actually physical mechanisms that can explain all these physical phenomena that we actually measure.
Yeah,
And
but
we
you
don't
can't
have
use
to
the word.
invoke bending space-time in order to do it.
Yeah, but you can't use the
Furthermore,
word. Yeah. Oh, sorry.
Furthermore, when you look at some of these things that you're talking about, like the astronomical observations, we know that we can see things change in the sky. But when you try to attach dynamics to it, you're already using a broken system to begin with. There's already so much presumption that's baked into that they're having to try to account for. When you say that it perfectly predicts it, it's just not the case. Our entire universal model is completely off. 96% of the energy in the universe is unaccounted for. 80-something percent of the
There's
mass.
like 4 or 5 points you've made now, right? You're kind of drifting off. I need to respond to something.
I'm trying to
Yeah.
address one by one the things you said. So, anyways,
Yeah, but you're making a lot of assertions
John,
that are
you
not
have to let
true,
other
and
people
then you're
talk.
conflating things like dark matter. You're going off into curved space
John,
time. A lot of things
I
I
did
have to
not
address.
interrupt you.
Yeah, but
Anyway,
one point at a time. Then I mean, this is like 5 points I have on my
okay,
list.
and you named off like 10 things, and I didn't stop you. So, anyways, there's so many points right there that things that you list as this exclusive evidence of relativity. It's exactly what relativity predicts, et cetera, et cetera, et cetera. If you just simply look into all of these phenomena one by one, you will find every single time that it is not an exclusive observation or the quote unquote prediction given is either A, not mutually exclusive, or B, non-physical and inferred via a priori presumption, affirming the consequent, begging the question, etc. We know, for example, I'll give you an example of one of these. We know that people use all the time an example of a proof of relativity that's supposed to be mutually exclusive
No
and
proving relativity.
can't possibly be explained by any other system. People will point to muons, right? They'll point to muons and be like, look, we detect muons at the surface of the Earth, but they're coming from the sun. But the half-life of a muon at rest is so short that it should never make it to the surface of the Earth. So what must be happening is that they must be experiencing time dilation because they're moving so fast, and in their frame, their time is moving more slowly, so they're able to meet the surface of the Earth before their half-life expires. And it's like, okay, relativity explains that, but maybe we could just look at it from a different point of view. There's actually two things that would explain it as well. Number one,
Let me know when
being
it's
that okay,
Yeah.
there's two things.
I think he's talking about neutrinos, not muon.
No, I'm talking about
muons. Yeah, he's talking about muons.
So, number one, we know that the half-life of subatomic particles at rest is different than that of particles in motion, as evidenced in particle collider experiments. So, that doesn't have to be from time dilation. Literally, you could attach a physical mechanism to it, such as they're moving through ether. You got these little vortices, right? Vortex ring theory that are moving
Let me
through.
know when it's my turn. I got such a list of.
I got you. I got moving through. I just want to finish the muon thing, and then you're good. moving through a fluid dynamic ether, which it itself is what they're made of. So they're literally picking up fluid as they're moving through it, which is offsetting the decay rate. So it slows it down when they're moving. Number two, the explanation that they give for muons is actually already flawed because they violate Lorentz symmetry. Because what they do
It
is
keeps on coming. It keeps like,
they
please,
invoke
please.
they
Mike,
invoke a time dilation without invoking a length contraction. Time dilation
What?
and length contraction are always
oh
conjugate.
Lordy, please. Is it ever going to
They-
be my turn? There's so much wrong here.
They're length contraction and time dilation always happen together at the same time. You can't have one without the other. So they find it very easy to go to the muons frame and say in the muons frame the time is dilating, but they also equivalently would have to also be able to say, well, in the Earth frame the length is contracting. No one in their right mind is going to say that the length from the ground to the sky in the path of a muon is shrinking in physical reality. So they just don't talk about it. Did he leave?
Yep.
But that's what they do. They say it's time dilation, but then they forget to bring up the symmetry and the length contraction. So that's just one example of many. That's just muons. And there's like 10 other things on his list. You'd have to go through one by one. I encourage you to go to the Obsidian database. All this stuff is addressed.
Yes, it is.
That's the longest response I've gave in this entire conversation today. Every other one I've tried my best to make it concise. He's literally rambled on and monologued for so long the entire time when so many people are being patient to him. And the one time someone actually has to answer at length, he gets mad and rage quits.
Yep. See, that's what he does. He goes into professor mode, and then he wants to teach everybody in the room, like a lecture. And then nobody else is allowed to speak for 1 minute.
Well, he got muted. He got muted for butting in, and that's probably why he left.
Probably. Well, he got warned
if he had
about
waited
400
more
times.
seconds, I would have been finished. I was literally at the end. I told him as soon as I finish muons, you're good, man, because I wasn't going to go. I was never going to have time to go one by one through all his things. I just wanted to give one example. But look, dude, we went in circles with that guy on Aries, right? Like literally gave the same explanation 4 times, wouldn't address the problem, would just hand wave it by saying relativity explains it, you just don't understand. This is what they do every single time. Anytime you bring an actual substantive point or a numerical point to the table that falsifies their paradigm, they're just like, you just don't understand it, and relativity explains it. As a hand wave generalized statement with no specifics of information to actually back up that claim numerically.
Awesome job, Piezo.
What was the thing you were talking about last time you were here, JC, with the light firing through a stream? Was it in either direction? I thought that was really interesting.
Oh, you're talking about Fizeau's experiment. Yeah, that also violates relativity. It's hilarious that they just neglect that and try to say they say this is what they do. Literally. There's a quote unquote physics Bible. It's a textbook. It's like the modern, it's like general physics or whatever for engineers and scientists or whatever. Anyways, in that physics Bible, quote unquote, they explain Fizeau's experiment. And they talk about how you can explain it relativistically. They give this whole derivation, like using relativity to try to explain it. But then they acknowledge, like, actually, this effect was perfectly predicted by Fizeau in 1818 and experimentally confirmed by Fresnel in 1851, 33 years later. Fizeau derived this formula theoretically. He theoretically derived it 33 years to it being proven by using a model where he based a refractive index off the compressibility of ether in a material. And that formula still stands perfectly accurate to this day, even though the causal mechanism is disputed, right? They can't argue that Fresnel's formula is accurate because it is. It's 100% perfectly accurate, but his explanation as to the causal mechanism involved ether, and they can't have that. So it becomes this like curiosity in the history of science. But when he did that stream of water experiment, he just basically had a interferometer set up, in two streams of water, one stream of water moving to the right, the other stream of water moving to the left, and he shot light through both of them in the same direction and recombined it at the other side. He found that the velocity of the light was actually added to or subtracted from by the velocity of the water at like a 44% ratio. So it was C plus or minus the V of the water ratioed against its refractive index. Now, you're literally not allowed to have that in relativity at all, because what happens is if you go to the frame of the water and you are an inertial observer centered inside the stream of water that's moving relative to the lab, inside the stream of water, you don't see yourself moving, the world's moving past you or whatever. When you see the two light streams, right, you're in the stream of water, if you fire two light beams front to back and back to front, you'll see those two light beams moving at different velocities. That violates relativity, because in your inertial frame, you've got two different speeds of light.
That does not violate relativity in any way, because you're talking about applying the refraction. It is refraction involved. There's a medium involved. That is not what relativity is talking about. You understand?
You're fundamentally incorrect, sir.
I am correct, sir. I don't think a lot of people understand relativity very much. I think it's just attacking Einstein, attacking consensus, attacking the words gravity that you guys are inferring here. And we need to really get serious about what relativity really is. And somebody needs to break that down for you guys, and I can do that for you.
You're doing the same thing Omnivore did when he was in here discussing this with me uptime. You're trying to say that because this is happening not in a vacuum but in water, it doesn't violate relativity. Well, hold on. Relativity is not said to only apply in a vacuum. It's said to be part of the laws of physics that are equally valid in every inertial frame in the universe. Everywhere. The laws of physics are universally valid. So it has to be valid in every frame. And to cut to the chase and make it short, I'll skip to the end of the conversation I had with him to try to save us all time. He tried to do what you did, and he referred to, well, it's because of refraction. And I was like, well, isn't the water the same throughout? Isn't it one uniform moving stream of water? And obviously he would have to answer that yes, and then he would still be stuck in the same boat. So then he said, well, refraction is actually happening on like an atomic scale, right? Like the actual water molecules themselves are absorbing and emitting light. And I said, okay, let's play your game. If you go down to the molecular scale, to the individual molecules of water, you say your water molecule is absorbing a photon from one side and emitting it out the other. Would you say that it's absorbing and emitting at the same rate in every direction, right? Because it's absorbing and emitting at about the speed of light, right? Or, the speed of light times the refractive index. So front to back, back to front, top to bottom, bottom to top, left, every direction. It should be absorbing and emitting at the same rate. Yes. Oh, okay. And then he thinks about it and he's like, well, yeah, but you got to remember the stream of water is either moving towards the photons or away from the photons. I was like, oh, you mean like C plus or minus V? You literally can't get away from it. It's the only explanation that satisfies it, and is what is used to model it in the lab and is predicted. It's C plus or minus V in the frame in which the water is measured, or the light is measured. And it happens in the lab and in the water.
Yeah, but what is important to understand that relativity, is talking about how things move within your reference frame, right? It's dealing with, like, light moves at a constant speed. That's a universal constant. That's a consensus, right? So if you're measuring speeds going through different mediums, you are definitely not talking about relativity. You're simply talking about how light behaves in a medium. That's all you are talking about. And that has nothing to do with what relativity is bringing to the table, brother. Nothing at all.
Can you explain relativity to us?
Wait. Don't get away from what he just said. It's important. You just said that it's in a different medium, right? But I said within the water. So never leaving the water, never changing medium, just staying in the water the whole time, right? There's no change in medium. The light speed as you said, should be constant. If we're in the same medium, I should have the same speed for light. But specifically, what Fresnel drag experiment performed by Piezo showed is that in the frame of the water, that you get two different speeds of light based on the direction that the light is fired.
No,
that is anisotropy. Yes, you do.
It's based on the refraction of the medium. Refraction slows down how light flows. Right, that's what it is.
Is the refractive index directionally dependent?
It's based on the refractive index of the medium.
Is the refractive
You
index
got nothing,
changing
dude.
based on direction?
Ask that question again, sir. I didn't hear you.
Does the refractive index of water change based on direction, front to back or back to front? Is it different front to back than it is back to front?
No, it does not.
Okay.
It does
Of
not.
course.
Exactly.
Right.
So
because
then that
water
doesn't
has a
explain it.
refractive. Right.
Because
Right.
in his experiment,
If-
the
if-
velocity of light was different in two different directions within the water.
But he's talking about observing the water from a certain point of view, right? So when the light hits his eyes, or how he's looking at it, obviously there's going to be it has to travel a certain distance.
They travel the
Right.
same distance. That's the point. He
No,
literally sends two beams of light across a rectangle. Okay. He starts on one corner of the rectangle, sends one beam across the top and the right, another beam across the left and the bottom. They recombine at the bottom right corner. Because it's a rectangle, right? The one L and the other L are the same length. The two light beams travel the exact same distance. When he does it in stationary water, they arrive at the same time. But when he puts the water into motion, one beam arrives faster than the other does.
Again, the point that you're missing here is if the water is flowing, it is changing its consistency, right? Throughout that entire distance. So what he needs to do is have water flowing in the entire apparatus at all times. So that means when the water is flowing, you can't tell what direction it is flowing. That's what he needs to do. You can't. Again,
what does that even mean?
Okay, tell
We're
you
in the laboratory watching the water flow. We know which direction it's flowing. I'm standing looking at the water flowing.
If you are seeing the flow of the water, there's already a consistency change. You should not be seeing the flow of the water at all. If this is the point of the experiment. The point of the experiment.
We know the water's flowing because we're pumping it through a pipe, silly.
Yeah, yeah, but again,
we know it's flowing. I'm putting pressure on the pipe, dynamically pumping it through a stream.
Again, if the water was flowing consistently in both directions, brother, the light will never the refractive index would not change at all.
The refractive index is not what's changing here. It's the velocity component, right? What's happening is this Fresnel drag coefficient. He found that there's a Fresnel drag. Basically, the carried velocity of light in a medium is ratioed against the square of the refractive index. So that if you put that medium into motion, a certain percentage of that motion will be added to or subtracted from the light's velocity. And the percentage is determined by the refractive index's square. So every single medium will have a different drag coefficient, right? Water carries about 44% of its velocity into the light. A different fluid would have a different percentage, but they all do it. And it's based on how compressed the ether is in that material, because the more pressure on the ether, the more the light slows down in it.
No, brother, the experiment is not measuring light. If the water is flowing consistently, no matter what direction it is, light will be subjected only to the refractive index of the water. Doesn't matter what direction it is flowing.
Well, then explain why in his experiment, when he caused the water to have laminar flow in one direction, and he caused the light to move against or with it, the light changed its speed.
He was not doing light. Light is
Yes,
not
he
his
was,
thing.
bro. It's literally,
No,
look at the experiment. He
Fernell,
pumped the light through
Fernell is
water.
not doing light. Fernell is doing airflow. That's what he's
No,
doing.
bro, it's light
Yes,
in water.
no, brother.
Literally,
That's-
Google it right now.
Google.
Are you
sir,
literally trying to say that Fresnel did not put light through a stream of water?
He is not doing light. He's measuring airflow. He's measuring air pressure.
You're literally
That's what that
lying,
experiment.
bro.
That is
Everybody
what his
in there
experiment
has
is.
Google
What
at their
you have done.
fingertips.
Okay, brother.
Okay,
Okay, let's
we
relax.
need
Here.
to
Let's all
pick a new
relax. Let's relax.
person.
Let's
This
take a
isn't
deep breath.
even coherent.
Brother, what he's doing? No. Come on, no. He's giving you an experiment that was not for light. Come on, brother.
It literally
Everybody
was
Google it.
for light. Use Google, bro. You have a keyboard in the internet. Every single person in here is fact checking you and thinks that you're speaking nonsense
Oh,
because
really?
the
Everybody
first thing
fact
that
check.
popped up.
Look up Fernell's
It just
experiment. Fernell drag. Everybody go ahead. We're not talking about light. Everybody, come on.
What
now.
are you talking about? It literally
Okay.
is an experiment about the refractive index affecting the light coefficient of drag.
Is this brother Witsit, the real brother Witsit here?
yes, Piezo is correct. Take a break and look it up because you're
Okay.
speaking
He's
nonsense.
not correct. He's not correct. Come on, brother. Come on. Be honest, man.
Dude, he is correct, bro.
Okay, read what you're reading from the internet. Go ahead.
I've already read
Okay,
through these
I'll
papers
read it.
experiment.
Go ahead, read it, brother.
Oh, I'll read. Oh,
Fernell,
yeah, wait up.
Fernell drag.
Calm down.
Go
Calm
ahead,
down. This
Fernell.
is embarrassing, but I got you.
I got
This is embarrassing. Bro, you should just calm down. But look, I'm gonna Google it on my other phone real fast, but I just looked it up. I don't know why you're doing this. And by the way, everyone at home can do it as well. Just type in the experiment name. That's all you have to do.
Yeah, Fernell drag. Everybody.
Yeah, that's right. Okay. Okay. Oh, it's not right. Just a second.
Like the delay there.
Why are
Everybody.
you laughing? Dude, I have it pulled up on listen, I have push to talk on, so I can't change windows and read at the same time. So I'm sending my other phone the screenshot.
Oh boy. Go ahead, brother.
Yeah, you're not at home yet. You're still in Chile, aren't you?
Yes.
Yeah.
Okay, here we go. The existence of Fresnel dragging resulting from movement of the medium through the ether was directly demonstrated in 1851 in an experiment using light transmission through moving water that produced the predicted phase shift rather than a null result. And this is simple test of special relativity involving Fresnel drag and light propagation. It's just the first paper that pops up. I'll drop the link to the paper.
Yeah, go ahead. Drop the link to the paper, brother.
I got you.
Are you still talking with them? What's it? I don't want to cut you off.
No, I was just tired of hearing him say that. So
Yeah, I mean, like his position shifted from defending the light in the water as not changing speed to then realizing, oh man, you can't do that, to then changing it to saying he wasn't measuring light in water, he was measuring air, which is like probably the worst take you could have on this because it's just disproven in like 5 seconds with a Google search.
Yeah, this dude was in here last night talking reckless as well, acting like he was in here teaching us stuff from his science Discord. I was like in bed. I wanted to come off mute so bad, but I can't even
Well, look,
remember what we were talking about.
So, like what Bull Knight just said in the chat. So he quotes the thing when he repeated the experiment with air, he did not see the same effect. Yeah, that's making Piezo's point.
Right.
Like, what the hell? The actual test, dude. Oh my gosh.
What
Yeah,
is wrong
exactly.
with these people? Like, why
No,
can't they
guys.
see that?
The point is, we're talking about airflow. We're talking about the medium, right? With Fuzos is the one that is doing the light measurement, right? So where this whole thing about using this to dispel special relativity is the point of my discussion here. You understand me? It doesn't even come close to dispelling any kind of special relativity.
That's a
I'm
cool
trying to get you
story,
guys to
bro.
understand that. Yeah, I'm just
He's
trying to
actually
get.
trying to get you to understand the base premise of the test before he can even walk you through to the fact that this proven principle ends up falsifying the entire heliocentric model.
The
That's what's actually
heliocentric model
happening.
is not falsified at all in any way,
Yeah,
shape, or form.
you
In
want
any
to
way, shape, or
bet?
form. Yeah, I
You
can.
want to bet?
Big one. Again, this does have nothing to do with heliocentric, whether the shape of the Earth is a sphere or not. Special relativity is talking about the speed of light, right?
I
So we're
just
talking
pulled one
about.
Okay,
up
listen,
on
brother. Listen,
the
he's trying to
regular
make sure
guys
you understand.
coming in today. So it's a crew who I think.
Oh, I think you're hot, Michael.
Yeah, can you give me maybe a phone number of one of the crew members just so that I can give them a
Does it?
call?
Someone help him
Because
out. He's hot,
in the
Mike.
past,
Right. I mean,
Thank you.
flat earthers
Wait up,
observe.
Let me say something, man. Jeez, Lee. All right, look, what he's trying to do is make sure you understand this concept. This concept is not denied. They try to come up with special relativistic explanations for it, sir, but this is a well-known, established phenomena, C plus V relative to the motion of the medium. Okay, your paradigm is that the light doesn't ever change speeds, actually, and therefore it's increasing or decreasing its total distance, blah, blah, blah. Okay, now the point is that you need to understand and acknowledge that concept because it becomes very relevant in the conversation about heliocentrism when you fast forward a little bit and realize that that was the foundation for the postulation of Airy's failure. Okay, so he utilized this known demonstrable fact to come up with his test. And that test definitively disproves heliocentrism. It disproves the claim the Earth is moving objectively.
No, not in any way, shape, or form. Any way, shape, or form.
Is that your argument?
Yeah, you observe you observe there's a 24-hour sun at Antarctica, right? That is not going to happen on any flat Earth in any way, shape, or form. Not even close.
How about you address the point?
Right. So, but yeah, let me address the point.
You just like overtly deflected right there.
Yeah,
Is
yeah.
that what
No,
that was?
okay. I'm addressing the point here. The point is you have Foucault's pendulum, which detects the rotation
Deflection.
of the
Deflection.
you have you. Okay, listen. Airy's failure was a poorly done experiment. Why? Because only refraction slows down light. Only. If the water is flowing consistency, no matter what direction it is flowing in, light will remain constant speed depending on the refractive index of the water. It doesn't matter how you spin it or how you throw it or how you mix it up. It will remain constant based on the refractive index
All
of
right,
the
let me ask
medium.
you a really
End of
simple
story.
question. Okay?
Not the
No, it's
flow
not
of
end
the
of
water.
story. Listen, this is a really simple question. Okay, if I shoot a laser across my room through the air, and then I shoot the same laser across my room through a fish tank that's the length of my room, which laser is going to get to the end of the room fastest?
Come on, the one that goes through the ear, brother. Come on.
Okay.
Oh, weird.
Yay. So
Let's
there
just
is a
disprove
difference in the
ourselves without
propagation.
noticing it.
Yeah, brother.
Yeah, okay.
The refractive index of the water slows down the light. That's it. End of story.
Okay,
So
now do you understand? Do you understand what the test was, bro?
He doesn't get it.
Okay, again, you fire the laser through the ear to the wall, right? Correct?
We're talking
and
about
then you
Airy's
fire the
failure.
Yeah,
laser,
you've
here,
already
okay.
acknowledged that it's slower. We can just move back to the
and you
test.
fire the light
Piezo,
through
do
the
you want to
water.
do you want to do this with this guy?
Right. Brother.
No, dude, I was enjoying. He actually listens to you a little bit better, so I know that you're like
Right.
busy and stuff, but at least he's listening to you.
Yeah. Again. Only the refraction, the refractive index of the medium slows down the light. That's it.
So
Nothing
the
else.
point he's trying to make, uptime, you acknowledge that it slows it down. So in Airy's experiment, that means that the light would have also slowed down in the telescope since the telescope was filled with water, correct?
But the water flow. Come on, don't change it
No.
up.
Oh my god, dude!
What
There's no
water
water
flow?
flow in the
What are you
fish
talking
tank.
about,
You
dude?
No,
that
remember,
that laser would get there slower.
remember, he said the water flowing in a different direction, opposite directions, right?
This is
That,
a different thing.
A
Do you
different
not
experiment,
no,
bro.
we're
do you
not going to
not
change
know
it.
Airy's
Why are we
failure?
changing? Why are we changing?
Water's
Stay
not
focused.
flowing in Airy's telescope.
Yeah,
Jesus.
like look, let's all calm down. I need you to listen to what we're trying to tell you, okay? The fish tank in my room, the water isn't moving. I shoot the laser through it. It's going to go slower than if I shoot it through the air. Okay. We're going to
Correct.
now take that principle to Airy's failure. They
Oh, wait.
looked at starlight through a telescope. Then
Right.
they added water to the telescope.
Right.
So just like the fish tank in my room, the starlight, now has to go through the water, thus slowing it down. Do you understand? Okay, that means you do understand.
Yeah, I'm trying to get to speak. I think the mods are getting a little upset with me.
Don't do that. Yeah, don't do that. Yeah, you're going to be removed from the conversation if you're going to do that. I muted you because you were interrupting, so you need to mute your mic when someone else is speaking. And if you're going to do any more funny business, we're going to move on without you. So, but go ahead. Your mic's open. Go ahead.
No, I was just showing respect. Okay, that's all I'm doing. Okay. Yes, brother. The water is a different medium from the air. Do you understand that?
Yes.
Okay. The water has a different refractive index than the air. Do you understand that?
Yes, it does.
Right. So therefore, light is going to slow down through the water compared to the air. Do
There we
you
go.
understand that?
Yeah, there we go. Now let's talk about the
Let's
test. So the
talk about the
light
test.
went through the light went through the telescope. Okay, there was no water. We had to tip the telescope at an angle to keep the star in the center of the telescope. The heliocentric model claims that's because the Earth and thus the telescope is moving underneath the starlight. So the star is actually above us, coming straight down to us, but we're moving out underneath it. So, in order to see the star and keep it in our telescope, we actually have to tip the telescope at an angle. This is called stellar aberration. The analogy is rain. If the rain is falling straight down, but I start running through it, it'll look like it's coming in at an angle. So, the test, what was actually causing the aberration, Airy had the brilliant idea to add water, a different medium, because it would slow the starlight down. Now, if the telescope itself connected to the Earth were actually the cause of the angle because it was moving underneath the starlight, as you added water and slowed down the light, you have now increased the amount of time it's going to take that light to get through the telescope, which means you've increased the amount of time that the Earth would allegedly be moving underneath it. Thus, you've increased the distance that the Earth has moved underneath the light. So when they did the test, it did not change based on the claim of orbital velocity.
Uh-oh.
I see where you're making the mistake, and we already looked at this. Yeah. Again, my friend, everything on Earth is moving, including the water in the telescope. Everything, right? So if you're adjusting, trying to keep the star within the middle of what you're looking through to view it, if you're doing that, you are not going to see any kind of change because already the change is occurring as you are moving, right? The water is moving, you are moving, so you are going to, whatever change you saw without the water, you are going to get the same change, right?
No.
When looking to detect motion. We're talking about motion here. We're only talking about motion. So
You still don't get it.
No, you're not listening. So when you're looking at it through the water, you are only seeing light flowing down to your eyes. That's the only thing. You're not detecting motion. You are only seeing light flowing down to your eyes. The refractive
Let's
index
see if we
of the
can
water.
go.
And that's
Let's go
it.
step by step.
There
Make
is
sure that you understand.
nothing to do with motion in that experiment.
Yeah,
Okay. Do you know that the mainstream model's claim is that the reason you have to tip the telescope is because the Earth is moving? That is the
sounds like
mainstream claim.
motion.
The cause of stellar aberration in your model is orbital motion. The mainstream claim is you have to tip your telescope because the Earth, thus also the telescope, which is attached to the Earth, are moving. Do you understand that?
That is not what they're saying, brother. But go ahead.
Okay, that is what the mainstream. What we absolutely see is that to keep a star in the center of your telescope, you actually have to tip your telescope. Now, the mainstream model says that the reason you have to do that is because the Earth is moving underneath it, like running through the rain. They say the starlight's coming straight down to you, but since you're moving, it looks like it's coming at an angle. It's an apparent deflection. Like if you're running through the rain that's falling straight down, there's an apparent deflection, an apparent angle change. Because actually, the rain's falling straight down, you just started running through it. Now, obviously, you could be standing still, and then the rain could actually be coming in at an angle as well. So they developed a test to determine or distinguish between the two options. It's
Here
very
is
simple.
failure. The motion is going to be indistinguishable to the telescope. You cannot see because of relativity. Relativity is going to tell you that that motion is indistinguishable. You cannot see it. Using the rain example, the size of you and the raindrops is completely different. The proximity of the raindrops is completely different. We're talking about very distant objects, virtually indistinguishable to the telescope or to the human eyes. The only way you can detect motion is by using an offset. This is where Foucault's pendulum comes into play. The independent motion of the pendulum trying to get to the center of gravity. But the momentum of the pendulum
We're not talking about that.
No. I'm just trying to tell you, your Airy's failure is a failure to detect motion because it's not the proper experiment. These objects are too distant due to relativity. That is what we're talking about. So stop hanging your hat
please stop.
on these guys. It's over.
Okay, that is incorrect. The mainstream model doesn't claim that you won't be able to tell. The mainstream model claims the reason that the starlight comes in at an angle is because the Earth is orbiting through space. That is objectively the official claim. Just Google what causes stellar aberration. It's going to say the Earth's orbit. Because the Earth is orbiting the sun through space, it causes the stars to appear to be deflected. Okay? That's just factually the mainstream claim. The cause of stellar aberration is Earth orbiting. Okay, so what you just said would disprove your own model. This idea that you wouldn't be able to tell an effect of motion while on the reference frame of the Earth because the stars are so far away, or whatever you said, which was incoherent. that doesn't make any sense within your own paradigm. They claim the reason that you have to tilt your telescope is because the Earth is moving. Now, that means either that's the cause of the deflection or it's not. There is no in between. If it is, when we add water, it should deflect more because the light has slowed down. Very simple. All right, I'm not going to keep going back and forth. Someone else can jump in, though.
Yeah, a quick question for Piezo or Witsit, just because I'm trying to learn all this stuff. If we jump back to when John was talking, he was making it seem like with relativity, you're not really going to see the stars move or the stars just where it is. But my thought is, how can you get star trails in one evening? You know, the apparent motion of those stars and these tests like Aries, you can test, you know, directionality and motion, but then they want to say no, relativity saves the day, you just can't tell, but these tests have results. And I appreciate, basically I'm just saying I appreciate both of you guys for staying patient, not getting mad, because it is very frustrating to hear, you know, the nonsense just spewed.
Well said, Boston.
Thanks, Piezo. And I'm not trying to be mean or hate on anybody. It's just sounds to me like people scream, no, my religion is correct. Heliocentrism's not wrong. Relativity is correct. You have to believe me. Trust me, trust me. It's like desperate at this point with everything you guys have done on ether cosmology, with all the work Witsit's done and looking into the papers of old. Dude, we're not wrong. We've looked into it. They haven't. They don't understand it. And they're telling us that we don't understand it.
Yeah, man. That's the very common theme in here for sure. I just don't understand how someone can argue that strongly from ignorance. Now he's gone. Yay.
Well, where did John go? What was up with that? It was really nice, the conversation, and then he just bounced.
He's out of his mind too. I think he got server muted and he bounced.
Who, John?
Yeah, some dude in here named John something.
Yeah,
Well,
he's some. He's a like retired PhD.
I'm going to take this moment to plug Ether Cosmology on YouTube. Just go to Ether Cosmology and just start watching videos. If you haven't listened to Alan, Stone, Piezo, Shane, break this stuff down, because you can learn there and they're not steering you wrong.
Oh yeah, space audits too. I didn't know if Ether Cause is still up to date because I haven't checked it a lot, but I really encourage you guys to check out this July 9th thing though. I think it's super interesting. I hadn't seen it physically 3D modeled before, but it's a doozy because essentially it's in the chat right now. It like that's impossible. Just look at that thumbnail. I mean, just that thumbnail alone is impossible in their model. Like, is there an answer for this? I don't think there is. I haven't even seen anyone try to address it. John was in here and refused to address it earlier. He looked at two different videos that were linked in the chat, was discussing those videos, and then I linked this one. I was like, "Can you explain this one?" And he's like, "Oh, I have trouble with Discord. I don't know what you're talking about. How to find this video?" And they're like, "Okay, I dropped it again. I tagged you. Just check your notifications." He's like, "Yeah, I'm not seeing this video. Wouldn't even touch it."
I'd like to give a quick shout out to my creator and God's word. It's called the Bible. I'm not that smart, but 7 years ago, I came up with the superfluid theory that the sky could be a fluid. And I just blindly trust that Rakia, the firmament, is above us. That's why I named myself Rakia, just faith. And it seems like it's coming true. So God's word could be true, right? Like, after all, use common men like myself that can't fully explain things, but just have the faith to prove to other people that's all you need. And he directed me into talking about the firmament, superfluid, things like that. I went to a random presentation at my local college. I wasn't enrolled at the college. I just went to a lecture. They were talking about quantum physics, quantum locking, superfluid, and then I started researching it, and it made sense to me, like, because I always question where all the helium went. So if the helium is being processed and turned into a superfluid as it goes up under pressure and temperature, then that would make sense of, what our atmosphere or medium turns into up there, and also can turn into a super solid at a different stage, which may or may not be what the firmament is made out of. So good luck.
Yeah, I want to thank you too, Rakia, for putting the work in. And I don't know if y'all knew, Joe Hanvey went on Strange World with the whole crew there, and then he went on Kingdom in Context last night and talked even more. And Will Duffy had said some crazy stuff in the text, because Sean Griffin posted at Will Duffy and said, when you do your press tours concerning this trip, will you be sharing that you interviewed a flat earther before the trip that predicted and is demonstrating a 24-hour sun within a firmament enclosed circle of Earth model, going to great depths to demonstrate the objects of how what you observed happens according to what God describes in Scripture as the shape of creation, and that he also disagreed with the two high-profile flat earthers who accompanied you on the trip that thought there wouldn't be a 24-hour sun in Antarctica. And Will responded to Sean saying, not sure who you were talking about specifically, when we know that Joe knows about Joe Hanvey and what he said. And Lindsay, Sean's wife, said, Will Duffy, brother, you really need to work on your dishonesty. Not only is lying not a fruit of the Spirit, it's a sin. And your lies have been on full display. You've already had to make a public apology once. It's not a good look. And his response was, he was responding to somebody else. Sorry, it's Adam Griffin. Let me see what Adam Griffin said. I don't see that. Shoot, I thought he was responding to Lindsay, but he did say to Adam Griffin, false. No one said there was a 24-hour sun prior to TFE. So I guess this is still relevant. How could he say no one said there was a 24-hour sun prior to TFE? And then to continue,
well, he's just
quoting,
just to clarify, he's saying like before he announced it, which was like
okay.
almost a year ago.
Yeah, he says, I have a video of Joe Hanvey saying last December he had a friend in Antarctica that there was no 24-hour sun. It seemed to me like he was saying, Joe, like basically no one told me that there would be a 24-hour sun. I may be misreading that wrong, because I got the people who was talking in these posts mixed up. But I mean, we just need to watch all this stuff, make sure honesty and consistency stays.
Did Mr. Witsit leave? I'm sorry, I had to take a call. I apologize.
No, he's here.
I don't want to
I'll
talk
step
about
down.
that anymore. No, I have not given consent.
It's enough.
Yeah. If you want to think you're free falling to a vacuum, brother, go ahead.
Sorry.
Yeah.
I'm sorry. I did not hear what you said.
I disengage. Respectfully, I bow out. Your arguments are just too much for me to handle, bro.
Yeah, it's okay, brother. I mean, listen, science is hard, and that's how it goes. I apologize, but I had to take a call. I wanted to finish the
No, it's all
discussion
good.
about
Just be
Airy's
careful. You're
failure.
free falling. You're free falling perpetually while changing direction, and there are no forces involved. So I got to watch out.
Yeah, that's exactly how I describe other movie.
Sure about it. Okay. But guys, don't you think that's funny that they claim that like we're free falling, changing direction perpetually, and there are no forces involved?
Well, it depends which fantasy model you go with, right? If
Well,
you
the
go with the
mainstream
Newtonian one or the Einsteinian one, you get to pick and choose.
Well, yeah. Newtonian doesn't work at all, so they got to claim the Einsteinian one, obviously.
Can we make a French Canadian room, please?
They would just be legally cross the border if we did that.
Think about how insane of a claim that is. Like something's free falling and it's changing direction, and there's no forces involved. Like what? Can someone show me that, like in a lab?
That totally debunks Newton's first and second law. That statement right there.
Right, exactly. That's why when they argue against you that it didn't combat Newton's laws, I'm like, oh my god, you guys are so wrong.
It's so bad. I know, it's brutal. Even Shanker and Feynman got quotes from them saying, Einstein debunked Newton's first law or second law or whatever they're talking about.
Completely incompatible. But hey, we can mathematics it away. Give it a little transformation, if you know what I mean.
Hey, I started in Jesse Montreal. Is Witsit here? Like here, or just not here, but here?
No, it's not actually him. It's a AI, a Witsit AI.
Yeah, he's currently free
Did you guys hear
falling.
that I'm a clone? Did you guys hear I got cloned? Have you heard?
Yeah. Where are you?
Yeah.
Are you in
kidding
the
me?
States
Somebody
yet,
really
or-
said that. Somebody really said that.
Yes.
Yeah, dude.
What color is your
Replaced by
hair?
an actor.
My hair is like brownish blonde. They did a pretty good job.
They bleached it? Yeah.
Are you still out of the country, or are you in the States?
No, yeah, I'm still in Chile, and then I'll leave the hotel like 1:30. My flight's at like 3:45, and then I'm like 24 hours of traveling.
Yeah, you got a ways to go. All right, be safe.
I was trying to get into Ask Witsit, or not really Ask Witsit. I just wanted to tell Witsit something. Witsit, that's the real you?
It's the real me, yeah.
All right, cool. Hey, I just wanted to say it was nice of you to go on Nathan's, but what a waste of fucking time, eh?
Yeah, and like what's funny is I accidentally clicked that Discord. I didn't mean to do that, and Nathan wasn't in there, and so they started talking to me. So I talked to him for a second, and then he jumped in, and I'm like, oh man, this is awful.
Hey, you just keep on keeping on, bro. Don't listen to the haters.
Yeah, for sure.
I missed
Hey,
it. What
everybody.
happened this morning?
You're just doing the same thing he always does, is like not let me speak, and then yelling and getting angry, and saying I'm a liar, and then talking about light traveling. What the hell?
Don't worry about any of that. Get home to your family.
Yeah, for sure.
Enjoy Christmas.
I know. I'm
For
like
sure.
excited to see my little girls.
I bet, dude.
Look, you got to understand the guy you were talking about before, our Jamaican buddy, he was trying to explain to me how helicopters fly on Mars yesterday. So, we got to take this stuff with a grain of salt, right? They're completely bought into the model. There's no way out for them at all.
You got to spin those blades really fast.
Yes, sir. So it's literally like arguing with Wikipedia. No insult meant to, but that's really what it is.
Well, did you tell him that traveling through outer space to Mars violates the second law of thermodynamics, or no?
We didn't even get that far because I wanted to watch a movie. It was like a hit and run yesterday. By the way, Yellowstone, the last episode, oof, man, at least Americans can still make movies. Awesome.
You're the second person that's told me that, because I was really into Yellowstone for a while, and then I quit watching. I haven't watched the last season, and they told me that the final episode was amazing.
Bro, amazing, bro. Amazing.
Beautiful country. My one of my family members is there right now.
I
Yeah,
got
it's
banned from
definitely
there
on
for
the
a year.
bucket list after that movie. I'm definitely got to go there. What a freaking countryside, man. But this was like an
Yellowstone?
Indian and American story. Like it'll bring tears to your eyes, bro. Like that, it was that good.
Yeah, I got banned from there.
Are you
Oh,
still
that's
on
where you,
the?
that's
Are
where
you
you
still
got
on the
back.
blacklist for Yellowstone?
What a
Banned
coincidence.
from Yellowstone as a U.S. citizen. That's hilarious.
Yeah. I think I'm allowed back now. It was a year.
That's not too
Would you
bad
dip?
then.
Dude, Yasuke just
I
posted
was.
this. This is Jaren's on Australian news.
Oh shoot. Yeah.
So this is going to hit major news potentially if it already hit that.
Oh, it's gonna
Nice.
go everywhere. It's gonna be
That's
literally everywhere.
exactly what this whole thing is. Beautiful news, bro.
Yeah, you got two opposing views. Obviously, you got the view that this is really bad for flat Earth, and then you got the views that it's good because it'll make a lot of news. So I'm obviously in the latter camp.
So do you think at this point it's possible that they kind of planted? Dude, I was looking at 100 proofs Earth is not a globe, William Carpenter, like 1880 or whatever. It says in there about the difference between the Arctic and the Antarctic. Basically, it doesn't say specifically there's no 24-hour sun, but it's like number 37 or something on his list. I read it the other day, but it basically indicates it's like saying how I'd have to go reread it. I just to give the exact, but it basically is implying how there's a difference with the sun in the north and the south, and how like similar to Gleason's claim, and that it proves it's not a globe because of that. So I mean, and it's in Robotham. So I mean, at this point, do you think that it was something that was artificially planted, to build all up to this? And then that implies that Duffy would potentially be in on something. Or do you think it's just a coincidence? Like, what is your? Because I mean, if they're going to hit it with the big news, was this the plan all along? Is to kind of plant this fake information, and then get it of the no 24-hour sun, get all the flat earthers on board with it as much as possible, and then take people there, show it, and then hit the big news that flat earthers were wrong or whatever?
Maybe, I don't know. I mean, I don't think it's that conspiratorial, like being around Duffy and seeing all the behind the scenes. I think, like, I don't even think he's going to continue to put stuff out. He's like pretty over it. But
Okay, so you don't get the vibe
and,
that he's anything like that.
no, right? And you can see where, well, if there wasn't a 24-hour sun, it would disprove the globe. Like the current model is a very specific geometric claim and stuff like that. So, I mean, I can see why someone would say that, but they may not have known. I don't really know. Also, at the same time, I think a lot of it may have been planted because if you even look into like Gleason himself, it's like, well, he had to put out a certain map based on the king's decree. So we've only been given a controlled story. So I don't put I don't put it past the realm of possibility that there was like very elaborate scheming going back a while.
Yeah, but it also could be that they might have planted that, or there could be some scheming back then. Like, it seems like they really started pushing the globe. Like when you think about like the 1800s and then into the 1900s, and then World War I, World War II, the whole way they got the globe like into humanity's mindset transitioned a lot through these years and through all that. So it could just be that like some of that was either planted or kind of created to knowing as like a pre thing, like knowing that when people started realizing there's no curvature, there's no motion, they have certain narratives like ready to go because they know people are going to be searching for information. And then from that perspective, it could be conspiratorial on that side that there was some planted stuff or some kind of preloaded agendas. But then it doesn't mean that this trip was necessarily planned. Like they could have just had that and then just waited for a flat earther to go there basically, or waiting for it to come out for people to figure that out, that there is a 24-hour sun there. And then now all they have to do, and if Duffy is not some kind of operative or whatever, he's just a dude, then he just happened to be the dude who did that. And then the controllers would then be like, oh, okay, this guy's going to take flat earthers there. Oh, he's taking Witsit and Jaren. All right, let's see what happens. And then, and then all they had to do is get their stuff ready to blast it in the news. That's another idea where it's like it's not necessarily that this trip was operative at all, but that there was a kind of planted information, and then now they're just capitalizing on it and using it for the media hype for it.
Yeah. And that's why it's so much better to go ahead and get, now we found out for sure, we know, like, boom, rip the Band-Aid off, you know?
Yeah.
So, yeah, I mean, I will say, being here, I'll just let you know, man, all the Globers involved wholeheartedly believe there is a globe. Wholeheartedly, bro. And
Yeah.
this is kind of proven by their, like, how they would so boldly make the predictions beforehand, and when I would make comments about what needed to be measured, they would do it. So, yeah, I mean, I think they just came here. They think, like Duffy thinks, that once they release all the different experiments, quote unquote, that they did, all of which affirm the consequent, that will be the beginning of the end of flat Earth.
Well, you're saying that's what they think it's going to be?
Yeah. So that's their perspective. It's like mission accomplished. It wasn't just the sun, they did other stuff. And then it's like stuff that we've all already addressed. Obviously, because the 24-hour sun wasn't addressed only because we didn't know for sure it was a thing. No one disputed the direction of sunsets below the equator. No one disputed that southern star trails exist. Right. So, yeah. I guess they're claiming that the weight matched the gravitational prediction of the globe.
Yeah. You know what's going to be tough for them, though, just on a basic level, if they're trying to say it's the end or whatever, but then what happens when, like, a few weeks go by, a few months go by, and it's even more, there's even more interest and more hype and more views and more everythings. It's that thing where it's like, I swear to God, guys, it's over. Like, next week it'll be over. Next month it'll be over. Like, what happens when it's just like months and months go by? Like, their own claim of whatever being over, thinking it's the end or something, is just they're going to debunk themselves. Just the fact that over time it's not going to happen. So,
well, some of them really don't want it to be over, right? Like, imagine FTFE. Like, he literally wouldn't have a job. So it's kind of like a bluff, I think. But, either way, I mean, I feel like for example, they had to come here and do this, because then if they didn't, then the audience would be like, oh, wait, so you're like doing this all for money. But yeah, it's like, well, I would just say, I think that like interviews and stuff is going to play a major role in what this does. And yeah, I knew it the whole time. I thought about all this. I knew we were going to go super viral. Told Leith last night she was going to be famous. I hope you're ready.
That's what this whole thing is about, breaking through to the other side, like the song, right? Regardless if you believe in Jaren or Witsit or their ideas, it doesn't matter. The fact that these guys are going to get the questioning of the cosmological model out, that's the main thing here. This is just the beginning. Then we can start talking about other things in their crazy model. This is just the beginning. Kudos to you guys.
Thank you, man.
Exciting times we live in, right? Like, imagine, like, your grandparents had World War II and the Great Depression. Your parents had, like, technology boom and things like that to remember, right? Like, those were the big things. I think our lifetimes are based on cosmology, right? Like the exploration of our planet finally, and trying to figure out things. It's kind of crazy, right? Did I say planet?
So, Witsit, is any of the flat earthers like flipping, quote unquote, like Lisbeth? I don't know what Jaren's exact takes are, or the Jonathan. Like, in terms of the media stuff, like, are any of them like going to be like flipping or whatever in the media kind of thing, or is that not going to be the thing?
No, I don't think so. I mean, Jaren said his position pretty clearly, that he did kind of push that model, and he thinks this doesn't work on that model. So he said he thinks he has the obligation to say he was wrong about that, and that he doesn't think it works on that model. But you know,
But he's not like, yeah, he's not like going globe kind of thing the way some people are trying to say he is.
no.
And then what about the documentary? Like, do you think that like with Jonathan, like I don't know if anything you want to share, but like does it look like that's going to be like on the positive side of things? Like, is it looking, just because you hung out with him and stuff? So like, I don't know what his plans are, but is it looking like that of all the media coming out that could be? I don't know what your thoughts are on that, like how that kind of the energy of that, where that might be going, or any comments on his filming?
Well, I think that they really want us in it, and they know we have final cuts, and so just on that alone, it has to be like it can only be framed a certain way, which is more like just a kind of non-biased documentation of what occurred. More like, look at this journey and trip that these people put their differences aside and went out to get the data or whatever. And it keeps telling me people are blocked or joining. Like, I don't care. Okay.
I would say that's a really interesting opportunity to kind of like interject with like the real problems with our position and like what the real context is and why we're not super worried about it. Like it's just more information, which is a good thing, you know?
Yeah. So we did an interview before we went while we're there. I was like super delirious both times, but whatever. And then and I'm like super tired. But I have one in like an hour. It's like everyone's doing like their after interviews with him. But obviously, again, like none of it can be used unless we agree. And we got Lise doing the same thing. So yeah, I'll kind of lay a lot of that out, like because if the thing ends with me explaining like this doesn't actually falsify flat Earth, and I get in some of the other major problems. If that's one of the last messages heard on the documentary, that's a huge win. In that case, I would let him put that in there.
Well, I
Yeah.
think, Richard, I think it was great that you guys went down there, and I really appreciate and think it's awesome that the way you interviewed there, the way you explained your position, and I from the very beginning, I didn't think this was going to do very much for the globe's fight, as it's kind of viewed as a battle between the globe and the flat earthers. So I think you left it on good in a good position for yourself and the team. So I'm just I'm glad it's not ending because I think the discussions are always pretty cool. But I think it's interesting that they think it's just going to die after you sell the 24-hour sun, it's over with. And no, you guys have explanations for everything, so it's not going to do anything. I think you were a little surprised that there was 24-hour sun because it kind of discounted all the the conspiracy theories of all the edited videos we did see. What there weren't that many, maybe 3 or 4. But yeah, you have there's this little model that you guys have conjured up, and it's very far fetched, and I don't think it makes a lot of sense to me. I mean, it makes sense how it works. It doesn't make sense that
Wow.
you would.
Balanced take from Zanuck.
Yeah, it doesn't.
Didn't expect that.
Doesn't seem like what we saw in the video could be a result of this conjured up, very complex optical phenomena or a dynamic. But I do appreciate that it's done, and you're standing by it, and you're moving on to the next experiment. I think everyone now should be planning a trip to Slack and do all the non-parallel vertical plumb lines. But that's my own feeling. But hey, good on you, and congratulations for going down there. I wish I could have been down there as well. That's a phenomenal trip. Not very many people in the world have seen a 24-hour sun or been to the South Pole, which is very it's amazing down there. The pictures were fantastic, and you guys did something really noteworthy, and you'll be looked at as pioneers for forever. You guys are famous.
Oh, thank you, man. Yeah, I do find so interesting about some of the flat earthers' responses is like, so if we had gone down there in the sunset, they would have loved us, you know. But since it didn't, we're Masonic actors or something.
I think
Well, whatever.
I think you're, in your deepest, thoughts, I think you kind of expected it to be 24 hours. I don't think you really were that surprised, were you?
No, no, no. I knew once the trip was actually happening, there was a 24-hour sign. Like I was pretty sure because
Right.
the trip wouldn't be happening if there wasn't one. I'm saying like what? So like once we're actually on the plane, I'm like, okay, I think we're about to see a 24-hour sign. Yeah. Um, and so that's fine. And Gio did a lot of digging and he did show me a video that was like seemed authentic and it was not propped up or anything. It had like no views. And I'm like, oh, look what Gio found. And it wasn't easy for him to find it, but
Right.
so yeah, like as time progressed, I became more aware that there does appear to be one. Sure enough, dude, there is.
Yeah. And I get your position, so I'm not really like, oh God, what else we have to show them? I kind of expected it. You and I are on the same page. I expected it as well. You expected it, and all those responses you gave were right spot on about your feelings about it, your interpretation of it, and it doesn't really do much. And I told people that were asking about whether this would be the ultimate proof and this would be the end of flat Earth. I said, no, it's not. It's not going to end anything. That's kind
No,
of a
I
false.
think it's a significantly important piece of data though. Um, because people would have just spun their wheels. At this point, any video could have come out and people would have been skeptical because there was some editing and stuff. Then people were like, "No, it doesn't matter." And um, this solves that, right? Where if you're actually a truther, like there were some flat earthers probably hoping it was cloudy and like that wasn't my mindset at all. I was like hoping it wasn't cloudy, and I was bringing things to try to see a sun through the clouds, and I was praying. And then we got there, and it was beautiful. Not like literally not a cloud in the
Pretty
sky.
amazing. I mean, pretty.
Yeah,
I
yeah.
mean, lucky too. The fact that you have all this invested time and all the build up, and you get down there, and not only was it like you saw the sun a couple times, you saw it almost the entire time, like cloudless. You see this spot circle around you, take its circular path up and down on the horizons. I mean, that was fucking amazing. You guys are really lucky.
And so well, 35 or so hours after we got there, it did start getting cloudy. And then it was just completely overcast, basically. Like there were tons of clouds. And they said this is very typical. And so it's kind of crazy. It was like the day before we got there and the day we got there was really clear, which is pretty wild. But I knew I was supposed to go, so I prayed about it.
What were they
Siren
saying
said
about
he
the
felt like he
levels?
was told to go see, so
What were
Yeah,
they saying
God,
about
it's like God opened up the heavens for you guys. A
no,
little
totally.
gap right there when you got there.
Was there any talk about
Sure.
how much ice is down there and like the climate change angle where they're saying, oh, we're losing ice.
No, because everyone down
Summer,
there is not super gay. So
not
it's
gay.
like everything. It's like, yeah, it's like there are like just real
Not
people
super
that,
gay.
yeah, you know what I'm saying? Like they're not, you can make like that joke there. Like dude, they're like some of the like toughest people ever, right? I mean, that's a brutal climate. So they're not real. I mean, obviously there are some,
Like there's not
veterans,
penguins,
but
on mass migrations to the exact, South Pole because all the ice is evaporating, sublimating.
no, there's not even, no, people anywhere close to where we were, you know what I'm saying? Like they would die because there's no food. Like there's literally nothing that they could eat. They
Right.
will never go there.
I was being facetious, obviously. I mean, they say actually people that are in the know are talking about Antarctica actually gaining ice over the last, several decades. The North Pole actually is losing, but that's kind of the balance of the world. And they just don't want to accept the fact that we're in a
It
dynamic
seems
environment.
weird. It seems weird that the North and South are so different, yeah.
Yeah.
But what I've never got about this concept is if I put a big cube of ice in a glass of water and then the ice melts, it doesn't overflow the cup.
Right. Well,
You know what I'm saying?
that's the other dynamic they never understand. Well, if they really want to talk about it, doesn't matter whether the North Pole loses ice because that's not going to change sea levels because it doesn't change the levels in your glass of water, like you said. What they're talking about is Greenland, losing water off the land and rolling into the ocean. That's kind of their position.
Uh-huh.
That Archimedes principle.
What his first point was, yes. Well, kind of.
Yeah, and look, I'll tell you guys, man, like I'm a truther. Okay, so as in like, I think this is very important and it's very fundamental to like my philosophy of life. Like, if you're wrong, that's a good thing. Like if you find out that you're wrong, it's not a bad thing. It's only a bad thing if you have like pride or ego. And then sometimes it can be bad if like you're telling other people something wrong, which is why I've done that a couple times and I've had to like try to quickly, correct the record or whatever. But I don't, like clearly what happens, man, when you get south, like the southern portion of the sky is lit up. If you're in a plane, you go towards it, you see the sun just doesn't set there. And as you cross like the kind of the arbitrary line called the equator, things start to look like they tip over in the sky, right? And when you look at the sunspots from corresponding latitudes, they look like they're rotated over. And obviously, the globe claims that that happens because we're physically tipping and rotating over antipodal relative to the initial position. So, that it's not a huge surprise to me that it matches because, for one, it would have to for the globe to be a thing. Two, that's how the globe was made. And this isn't extremely different from Southern Star Trails. It's slightly different, but so to me, it's very obvious that on a plane, something happens that's further out south that creates that makes it look like that, and the globe is claiming that's because you're physically changing position. Now, to make that claim, you have to claim that everything in the sky is really far away, and that the only thing that's really affecting how you see the sky is your orientation. So I'm saying, like your physical difference. And I intuitively just in no way think that's true, but I guess the point that I'm making is, um, like I don't know, it seems like some flat earthers aren't like that. Like they don't want to just know the truth and they maybe just really like the argument or whatever. I find that unproductive.
Or just going against the mainstream and not actually seeking the truth for the truth, but just wanting to go against the mainstream and clinging on to this because it's such against the man, the system, the government. You think that could be like part of it, that some people are just like latching on, maybe more belief based in a way that they're not really like seeking truth or wanting, to get further evidences and things, but they kind of want to cling on to it because it's like against the corruption of the system, but not actually being like
Yeah,
fully in it for all the truth layers of it.
yeah, and you have like a community. So, I mean, I just don't think that's a good way to live life. Like I know that there were flat earthers that were hoping it was cloudy. So that's just a good example of the mentality. Like, why would you hope it's cloudy? Like, I don't know, like why? That would suck. And not just for us who had to go through all that, but it would just suck. Like, what? Like, don't you want to know? We didn't know. Now we know.
Who was hoping it was cloudy?
I've just talked to some flat earthers and they've made comments in passing about how much of a win it would be if it was cloudy, and basically alluded to the fact that
What?
yeah, if it was cloudy, that it would be a win for flat Earth or whatever. So, and I'm so glad it wasn't cloudy. Imagine if we'd have come
I've
back
heard
thinking
that.
like, wow, they made it cloudy. We couldn't see. Maybe there's a conspiracy with the sun and it's not there. And they want to breathe life into the idea it's not there when we now know for a fact that it's there.
Yeah, I would have
And I know
thought
some
that's
people would say we
a
don't
win
know
for
for a
the
fact
globe.
that's there. So.
I would have thought that's a win for the globe, is that they could like, have it both ways. You know what I mean?
No.
You don't think so?
Do you win if? What do you potentially win if you believe in the globe? And then what do you potentially win if you just blindly believe in flat Earth, which proves a creator? Like, what side would you rather be on?
Well, the idea would be that they're spinning the wheel, like they're not actually progressing the argument. Like they kind of want people debating and arguing and everything. So it would just keep the argument stagnant. That's kind of I would imagine that
No, on
the
a
less
personal
they
level.
progress the argument. Yeah. I mean, I'm not talking about personal level. Obviously,
Yeah,
I
that's
don't
my
think the
question.
the globe paradigm is good. I'm just saying that if they didn't progress the argument, then that would be kind of a win for the controllers. So,
But on a personal level, like I put myself in there. I don't have to put anybody else. If I turn back to the globe, okay, like just decide one day I'm going back to the globe. What do I win? Like it doesn't. I don't get any benefit from it whatsoever.
Well, I would.
But
I would get.
but
I would get
believing
lots of
in
benefits
it,
from it.
well, you know what I'm saying, like spiritually or morally or whatever. Like all my stuff still works no matter what. If it's based on a globe and only works on a globe, then I guess I would lose that, right?
You would gain
but I
how the
don't.
lights in the sky work.
I guess, but you know what I'm saying, like if you're trying to be a flat earther or just believing in flat earth, you lose basically. You're getting ridiculed, you're getting, losing friends or family or whatever, but I think people are going through that because it's worth it to them. They just don't want to concede to the consensus just to get along. That's what makes a truth seeker, right? You're willing to take that risk. I mean, Witsit is a great example.
Yo, and check this out, bro. So this is what it actually is. This is what it should be, and this is what was, in my opinion, subverted. So it's like we were told the Earth's a certain thing, and specifically this globe that's tilted, wobbling, spinning, revolving around the sun, etc. Some people began to look into it. Larger numbers began to question it in modern times, and we found out that the evidence does not comport with that claim, and that the Earth is not what we've been told that it is. So the proper thing to do is say, okay, falsification is independent of replacement. I have no idea what the Earth is, but we have been misled as to the nature of the Earth. And we're just going to try to learn as much about it as we can. We just don't know what it is. Instead of that being the movement, which should have been like something that's very unifying for people, and it should have been like, okay, now let's all come together and demand answers, etc. It was, here's your replacement model served up to you. Go from one like rigid dogmatic model that controls how you see the world to another one, right? And that was the trick. Because if we actually were all just saying the evidence doesn't add up, we kind of demanded it be acknowledged, that isn't as divisive and it's not as good for anyone with like nefarious intentions in power. So that's like, and if anyone really like Witsit won't commit to a model or something, exactly. Like if anyone actually watches my content, I've never claimed a model, dude. I'm the one that coined the phrase falsification is independent of replacements. And I will always say, although I do think I can answer and I have better answers in many of the circumstances, certainly in terms of like cosmology in general and in, the cosmos. So I think that it's important that this happens because if what people did was the reason that most globers can't stop being globers per se, quote unquote, is because they need an answer for everything the globe supposedly answers. And they need a model that gives them all their answers. They need someone to have all the answers for them. So, some people broke out of that, but apparently they actually only did so because of another model. That's why you're seeing some of this reaction.
Absolutely, dude, because that's part of the like the programming in the first place is to like get everybody as children to be like, yeah, all these authorities figured it out, so just go to a job and just keep eating GMO foods and TV and all of that. But it's like, it was all presented to us. I would even say like, it's even a trauma to be lied to as a child, and to be lied to repeatedly, and to be lied to by like a large amount of people, like your parents are being lied to, and then the you know, all everything that's going on. Like that is like actually traumatic, because the child has to be like, why does something not feel right about this? Oh, I guess I'll just ignore that and just believe them. That's kind of like part of the programming. And so when you get that, and then with the globe model and everything and what they claim with it, just how that all links in to that. And then it's like we've all been traumatized just from that level. I'm not talking about like physical abuse trauma. Obviously those are different types of traumas, but just being lied to and then having that be a thing in and of itself. I mean, yeah, the word trauma is kind of a harsh sounding word but it is kind of a psychological type of a trauma, and even emotional. So then we've all gone through that, and then growing, you know, and then getting older and realizing some of these things. Like, I guess I was trying to link it back to what you're saying, that people want to just cling to a different model. They just want to be like, okay, the globe's false. What's this other thing? Oh, this AE map, there's this, there's that, and then replace it because they think that that's giving answers. And then if it's not giving all the answers, or that's proven wrong, then yeah, they would either have to be really on the search of truth to decipher that, or they might just end up being dogmatic about the model that's false, that, you know, because of the way that they already had that from the accepting the globe and wanting to replace it so badly and wanting all the answers. And if they don't have them, then it could kind of goes into a way where some people that like, they're not okay with continuing the process for truth without having answers, versus just being given answers and believing them and just integrating that. It's more easy to do that. Just be like, oh, here's a replacement model, rather than actually going on the whole search.
I got a question.